yakni mantan Presiden Republik Indonesia keempat. Kekhususan FK Unisma yaitu pengembangan di bidang keanekaragaman hayati dan pemanfaatannya sebagai penunjang pengobatan dan pengembangan tim bantuan medis dalam bencana dan kegawat daruratan yang berlandaskan keislaman dan Ahlus Sunnah wal Jamaah atau Aswaja. Fakultas Kedokteran Universitas Islam Malang telah mendapatkan status akreditasi B dari BAN PT 2011 dan LAMPTKes 2016. Saat ini terdapat 4 program studi di Fakultas Kedokteran, yaitu program studi pendidikan dokter, program studi profesi dokter, program studi farmasi, dan administrasi rumah sakit. Kerjasama dengan banyak universitas baik di dalam maupun di luar negeri terkait Tridharma perguruan tinggi dan pengembangan karakter dan kepemimpinan mahasiswa maupun staf pengajar dilakukan melalui berbagai program pertukaran pelajar, research attachment, pertemuan ilmiah, dan beberapa program akademik serta non-akademik lainnya.
Selamat datang di program studi farmasi Fakultas Kedokteran Universitas Islam Malang. Prodi Farmasi FK Unisma siap membangun generasi farmasi yang kompeten dan berintegritas. Farmasi bukan hanya sekedar meracik obat, tetapi juga meracik harapan untuk kesembuhan.
Prodi Farmasi FK Unisma menggabungkan teori dan praktik untuk mengembangkan kemampuan mahasiswa dalam bidang kimia farmasi.
Di laboratorium kimia farmasi terdapat berbagai macam peralatan canggih seperti spektrofotometer dan lemari asam.
Perlu diingat, laboratorium ini dipenuhi oleh bahan kimia. Untuk itu, jangan lupa memakai alat pelindung diri seperti sarung tangan dan masker.
Teknologi formulasi.
Selamat datang di Laboratorium Formulasi dan Teknologi Farmasi. Di sini kami melakukan praktikum dan penelitian pembuatan sediaan farmasi.
Bahan alam farmasi.
Di laboratorium ini berfokus pada penelitian dan pengembangan dari bahan alam. Selain itu, di sini dilakukan analisis dan ekstraksi dari bahan alam. Untuk mendukung keterampilan dan pengetahuan mahasiswa dalam penelitian dan praktikum, Prodi Farmasi FK Unisma memiliki fasilitas dan peralatan yang berlandaskan Islam Ahlus Sunnah wal Jamaah. Lulusan kami siap berkontribusi pada kesehatan masyarakat. Mari menjadi bagian dari kami membangun kesehatan bangsa Indonesia.
Dari sebuah pilihan, tapi kemana langkah harus melaju? Universitas Islam Malang hadir sebagai ruang bertumbuh dan melangkah ke dunia global dengan tetap berpijak pada akar nilai luhur berlandaskan Islam Ahlus Sunnah wal Jamaah. Di sini, mahasiswa tidak hanya belajar dari para ahli, tapi juga berdiskusi dan bereksperimen di laboratorium, perpustakaan, serta praktik lapangan. Dengan dukungan fasilitas modern, kolaborasi, dan semangat inovasi yang terus menyala, Unisma menjadi kampus unggul dan berdaya saing global serta melahirkan lulusan yang siap bersaing di berbagai bidang. Membawa semangat perubahan dan kontribusi demi kemajuan peradaban yang berkelanjutan. Pilihan hari ini penentu masa depan hebatmu. Bersama Unisma, terbang melesat menuju kampus berkelas dunia. Pilihan hari ini menentukan masa depan esok. Universitas Islam Malang menjadi ruang bertumbuh dan berinovasi. Berbagai program studi di Unisma telah terakreditasi internasional, unggul, dan baik sekali. Dengan pembelajaran yang inklusif di laboratorium, perpustakaan, praktik lapangan, serta peluang kolaborasi yang luas, Unisma siap mencetak lulusan berdaya saing global. Unisma, tempatmu melesat menjadi generasi berkelas dunia.
Fakultas Kedokteran Universitas Islam Malang adalah fakultas kedokteran pertama yang berdiri di lingkungan perguruan tinggi Nahdlatul Ulama di Indonesia. Ide pendirian Fakultas Kedokteran Universitas Islam Malang atau FK Unisma tercetus pada tahun 1995 oleh almarhum Kiai Haji Abdurrahman Wahid, yakni mantan Presiden Republik Indonesia keempat. Kekhususan FK Unisma yaitu pengembangan di bidang keanekaragaman hayati dan pemanfaatannya sebagai penunjang pengobatan dan pengembangan tim bantuan medis dalam bencana dan kegawat daruratan yang berlandaskan keislaman dan Ahlus Sunnah wal Jamaah atau Aswaja. Fakultas Kedokteran Universitas Islam Malang telah mendapatkan status akreditasi B dari BAN PT 2011 dan LAM PTKes 2016. Saat ini terdapat 4 program studi di Fakultas Kedokteran, yaitu program studi pendidikan dokter, program studi profesi dokter, program studi farmasi, dan administrasi rumah sakit. Kerjasama dengan banyak universitas baik di dalam maupun di luar negeri terkait Tridharma perguruan tinggi dan pengembangan karakter dan kepemimpinan mahasiswa maupun staf pengajar dilakukan melalui berbagai program pertukaran pelajar, research attachment, pertemuan ilmiah, dan beberapa program akademik serta non-akademik lainnya.
Selamat datang di program studi farmasi Fakultas Kedokteran Universitas Islam Malang. Prodi Farmasi FK Unisma siap membangun generasi farmasi yang kompeten dan berintegritas. Farmasi bukan hanya sekedar meracik obat, tetapi juga meracik harapan untuk kesembuhan.
Prodi Farmasi FK Unisma menggabungkan teori dan praktik untuk mengembangkan kemampuan mahasiswa dalam bidang kimia farmasi.
Di laboratorium kimia farmasi terdapat berbagai macam peralatan canggih seperti spektrofotometer dan lemari asam.
Perlu diingat, laboratorium ini dipenuhi oleh bahan kimia. Untuk itu, jangan lupa memakai alat pelindung diri seperti sarung tangan dan masker.
Teknologi formulasi.
Selamat datang di Laboratorium Formulasi dan Teknologi Farmasi. Di sini kami melakukan praktikum dan penelitian pembuatan sediaan farmasi.
Bahan alam farmasi.
Di laboratorium ini berfokus pada penelitian dan pengembangan dari bahan alam. Selain itu, di sini dilakukan analisis dan ekstraksi dari bahan alam. Untuk mendukung keterampilan dan pengetahuan mahasiswa dalam penelitian dan praktikum, Prodi Farmasi FK Unisma memiliki fasilitas dan peralatan dengan berlandaskan Islam Ahlus Sunnah wal Jamaah. Lulusan kami siap berkontribusi pada kesehatan masyarakat. Mari menjadi bagian dari kami membangun kesehatan bangsa Indonesia.
Dari sebuah pilihan, tapi kemana langkah harus melaju? Universitas Islam Malang hadir sebagai ruang bertumbuh dan melangkah ke dunia global dengan tetap berpijak pada akar nilai luhur berlandaskan Islam Ahlus Sunnah wal Jamaah. Di sini, mahasiswa tidak hanya belajar dari para ahli, tapi juga berdiskusi dan bereksperimen di laboratorium, perpustakaan, serta praktik lapangan. Dengan dukungan fasilitas modern, kolaborasi, dan semangat inovasi yang terus menyala, Unisma menjadi kampus unggul dan berdaya saing global serta melahirkan lulusan yang siap bersaing di berbagai bidang. Membawa semangat perubahan dan kontribusi demi kemajuan peradaban yang berkelanjutan. Pilihan hari ini penentu masa depan hebatmu. Bersama Unisma, terbang melesat menuju kampus berkelas dunia. Pilihan hari ini menentukan masa depan esok. Universitas Islam Malang menjadi ruang bertumbuh dan berinovasi. Berbagai program studi di Unisma telah terakreditasi internasional, unggul, dan baik sekali. Dengan pembelajaran yang inklusif di laboratorium, perpustakaan, praktik lapangan, serta peluang kolaborasi yang luas, Unisma siap mencetak lulusan berdaya saing global. Unisma, tempatmu melesat menjadi generasi berkelas dunia.
Fakultas Kedokteran Universitas Islam Malang adalah fakultas kedokteran pertama yang berdiri di lingkungan perguruan tinggi Nahdlatul Ulama di Indonesia. Ide pendirian Fakultas Kedokteran Universitas Islam Malang atau FK Unisma tercetus pada tahun 1995 oleh almarhum Kiai Haji Abdurrahman Wahid, yakni mantan Presiden Republik Indonesia keempat. Kekhususan FK Unisma yaitu pengembangan di bidang keanekaragaman hayati dan pemanfaatannya sebagai penunjang pengobatan dan pengembangan tim bantuan medis dalam bencana dan kegawat daruratan yang berlandaskan keislaman dan Ahlus Sunnah wal Jamaah atau Aswaja. Fakultas Kedokteran Universitas Islam Malang telah mendapatkan status akreditasi B dari BAN PT 2011 dan LAM PTKes 2016. Saat ini terdapat 4 program studi di Fakultas Kedokteran, yaitu program studi pendidikan dokter, program studi profesi dokter, program studi farmasi, dan administrasi rumah sakit. Kerjasama dengan banyak universitas baik di dalam maupun di luar negeri terkait Tridharma perguruan tinggi dan pengembangan karakter dan kepemimpinan mahasiswa maupun staf pengajar dilakukan melalui berbagai program pertukaran pelajar, research attachment, pertemuan ilmiah, dan beberapa program akademik serta non-akademik lainnya.
Selamat datang di program studi farmasi Fakultas Kedokteran Universitas Islam Malang. Prodi Farmasi FK Unisma siap membangun generasi farmasi yang kompeten dan berintegritas. Farmasi bukan hanya sekedar meracik obat, tetapi juga meracik harapan untuk kesembuhan.
Prodi Farmasi FK Unisma menggabungkan teori dan praktik untuk mengembangkan kemampuan mahasiswa dalam bidang kimia farmasi.
Di laboratorium kimia farmasi terdapat berbagai macam peralatan canggih seperti spektrofotometer dan lemari asam.
Perlu diingat, laboratorium ini dipenuhi oleh bahan kimia. Untuk itu, jangan lupa memakai alat pelindung diri seperti sarung tangan dan masker.
Teknologi formulasi.
Selamat datang di Laboratorium Formulasi dan Teknologi Farmasi. Di sini kami melakukan praktikum dan penelitian pembuatan sediaan farmasi.
Bahan alam farmasi.
Di laboratorium ini berfokus pada penelitian dan pengembangan dari bahan alam. Selain itu, di sini dilakukan analisis dan ekstraksi dari bahan alam. Untuk mendukung keterampilan dan pengetahuan mahasiswa dalam penelitian dan praktikum, Prodi Farmasi FK Unisma memiliki fasilitas dan peralatan dengan berlandaskan Islam Ahlus Sunnah wal Jamaah. Lulusan kami siap berkontribusi pada kesehatan masyarakat. Mari menjadi bagian dari kami membangun kesehatan bangsa Indonesia.
Dari sebuah pilihan. pilihan, tapi kemana langkah harus melaju? Universitas Islam Malang hadir sebagai ruang bertumbuh dan melangkah ke dunia global dengan tetap berpijak pada akar nilai luhur berlandaskan Islam Ahlus Sunnah wal Jamaah. Di sini, mahasiswa tidak hanya belajar dari para ahli, tapi juga berdiskusi dan bereksperimen di laboratorium, perpustakaan, serta praktik lapangan. Dengan dukungan fasilitas modern, kolaborasi, dan semangat inovasi yang terus menyala, Unisma menjadi kampus unggul dan berdaya saing global, serta melahirkan lulusan yang siap bersaing di berbagai bidang. Membawa semangat perubahan dan kontribusi demi kemajuan peradaban yang berkelanjutan. Pilihan hari ini penentu masa depan hebatmu. Bersama Unisma, terbang melesat menuju kampus berkelas dunia. Pilihan hari ini menentukan masa depan esok. Universitas Islam Malang menjadi ruang bertumbuh dan berinovasi. Berbagai program studi di Unisma telah terakreditasi internasional, unggul, dan baik sekali. Dengan pembelajaran yang inklusif di laboratorium, perpustakaan, praktik lapangan, serta peluang kolaborasi yang luas, Unisma siap mencetak lulusan berdaya saing global. Unisma, tempatmu melesat menjadi generasi berkelas dunia.
Fakultas Kedokteran Universitas Islam Malang adalah fakultas kedokteran pertama yang berdiri di lingkungan perguruan tinggi Nahdlatul Ulama di Indonesia. Ide pendirian Fakultas Kedokteran Universitas Islam Malang atau FK Unisma tercetus pada tahun 1995 oleh almarhum Kiai Haji Abdurrahman Wahid, yakni mantan Presiden Republik Indonesia keempat. Kekhususan FK Unisma yaitu pengembangan di bidang keanekaragaman hayati dan pemanfaatannya sebagai penunjang pengobatan dan pengembangan tim bantuan medis dalam bencana dan kegawat daruratan yang berlandaskan keislaman dan Ahlus Sunnah wal Jamaah atau Aswaja. Fakultas
Ladies and gentlemen, and the honorable guests, we would like to kindly ask you to turn off your mobile phone or put on silent mode as the session is about to begin. Thank you, and please have a nice seat.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen, our distinguished guests, esteemed speakers, and all of our wonderful participants. A very warm welcome to
Malang International Conference on Herbs and Toxicants 2025.
The effect of waterborne toxicants on health and its detoxification and mitigation.
I am Abdurrahman.
And I am Tazkiyah Azmi Salima, and we are
the
your
hosts
hosts
for today. It is a true honor for us to host so many brilliant minds here from around the globe here in beautiful Malang, Indonesia. Over the next several hours, we will delve into the critical, complex, and fascinating intersection of traditional herbal medicine and the challenging field of toxicology.
This conference is a vital platform for sharing groundbreaking research, fostering international collaboration, and setting the course for safer, more effective medical practices globally. We are thrilled to have you all join us for what promises to be an enlightening and transformative event.
And now, before we officially begin our opening ceremony and listen to our first keynote address, we have a small but important request for everyone.
To ensure all attendees can fully concentrate and enjoy the presentation without any interruption, and we kindly ask you all to take a moment now to put your mobile phone on silent or vibrate mode.
We appreciate your cooperation in helping us maintain a smooth, respectful, and engaging environment for all our speakers and colleagues. Innal hamdalillah nahmaduhu wa nasta'inuhu wa nastaghfiruh wa na'udzu billahi min syururi anfusina wa min sayyiati a'malina may yahdihillahu fala mudhillalah wa may yudlil fala hadiyalah asyhadu an la ilaha illallah wa asyhadu anna muhammadar rasulullah. Allahumma salli wa sallim wa barik ala sayyidina Muhammadin wa ala alihi wa ashabihi ajma'in. Amma ba'd.
We would like to extend our utmost gratitude to our honorable speakers, Prof. Chia Jung Lee, PhD from Taiwan, Associate Professor Muhammad Syukri bin Muhammad Aris from Malaysia, Professor Dr. Nurfilza Muhammad Mukhtar from Malaysia, Professor Ahmad Saifuddin SSE MPhil from Indonesia, Bapak Rio Risandiansyah Esket MP PhD from Indonesia,
and Surya Kenta Akmal PhD, Dr. Muhammad Afiq Zaki, Dr. Dini Sri Damayanti MKes, Dr. Fatin Nazirah binti Zakaria, Dr. Pramod Nair, Dr. Razif bin Dasiman, Dr. Chin Kok Yong, Dr. Pang Kok Lun, Yayasan Universitas Islam Malang, Rector of Universitas Islam Malang, Professor Dr. Andes Junaidi, PhD, Dean of the Faculty of Medicine, Universitas Islam Malang, Dr. Rahmat Riliana MKes, PhD and staffs, presenter and participants who are joining offline and online from all over the world.
all praises and gratitude belong to Allah and the merciful and the bestower of all blessings for granting us this opportunity to join this esteemed international conference. And eternal praises and abundant blessings be upon our beloved Muhammad sallallahu alaihi wasallam. May his light continue to illuminate our hearts and guide us on the path of righteousness and compassion.
Ladies and gentlemen, before we begin the session, let's start this conference by reciting Bismillah. Bismillahirrahmanirrahim. Ladies and gentlemen, please allow me to read the agenda for today. The first agenda is the presentation session from our keynote speakers, and the second agenda is oral and poster presentation, and the last agenda will be closing ceremony.
Okay, ladies and gentlemen, it is now time for our first agenda. For the next 3 hours, we'll have a presentation session led by our moderator, Dr. Sinta Kusumawati SP Neuron. Please allow us to read her short bio while she comes to the stage. Dr. Sinta is one of our neurologists and medical faculty lecturer. Her main topic of research is Parkinson's disease. Please welcome Dr. Sinta once again to the stage.
Thank you everybody and all participants and keynote speaker. Good morning. All our distinguished guests and participants, I am Sinta Kusumawati, and today I will be serving you as moderator in Symposia 2nd Malang International Conference on Herb and Toxicants MCIT 2025. Okay, before we begin, maybe I would like to invite all our keynote speakers to come forward the stage. To Associate Professor Dr. Chin Kok Yung from Malaysia. Give applause. And the second, Dr. Pang Kok Lun from Malaysia, maybe on Zoom, or online. And the third, Dr. Razik bin Dasiman from Malaysia. Give applause. For the first speaker is Dr. Pramod Nair online from Australia, and the fifth speaker is Dr. Fatin Nazira Zakaria. Yes, thank you for all speaker. Please, maybe welcome for our guest speaker in this session, and we will be give a warm round applause for all speakers. Okay, each speaker will have 30 minutes for their presentation, and after all keynote speakers are delivered, we will process with question and answer session. Okay, for the first speaker is Associate Professor Dr. Chin Kok Yung from University Kebangsaan Malaysia. He will present, he talk entitled the protective effect of Chinese medicine on bone degenerative disease. Dr. Chin, time is yours. Maybe before Dr. Chin present the topic, I will read the CV. Maybe committee show the CV of Dr. Chin. Yes. Okay, maybe I will read. Dr. Chin is Associate Professor from University Kebangsaan Malaysia and Department Pharmacology, and the interest in bone metabolism and degenerative.
Okay.
Oh yes. This is the CV of Associate Prof. Kok Yung Chin. Associate Prof. Kok Yung Chin obtained his degree in biomedical science and PhD pharmacology from University Kebangsaan Malaysia. He joined the Department Pharmacology, Faculty of Medicine, University Kebangsaan Malaysia in 2015. His research interests revolve around the use of natural vitamin E mixture in treating osteoporosis or osteoarthritis, and the epidemiology of bone health. He has published more than 240 journal article, mashallah. Applause for Dr. Chin. And 7 book chapter and 4 books. His work have received more 700 citation according to Scopus with a high index of 41. He has the privilege of receiving the Young Researcher Award from ASEAN Federation of Osteoporosis Society in 2017 and Malaysian Society Pharmacology and Physiology in 2018 and the Faculty of Medicine UKM in 2022. He was recognized as the top 2% most cited scientist in the world according to the list published by Stanford University or Elsevier. He served on editorial board of BMC Public Health and Frontier Endocrinology. He has also the current editor in the Chief of Medicine and Health, the House Journal of Faculty of Medicine UKM. Give applause for Dr. Chin. Dr. Chin, time is yours.
Very good morning, everyone. Thank you for the gracious introductions by our MC today, and also thank you for the invitations to the conference today. As you can see from our title, my title only hit half of the conference team, which is the third part, but not very, how do I say, familiar with the pollution and toxicant part, so just pardon me, okay? So today I'm going to give a talk entitled The Protective Effect of Chinese Medicines and Natural Products on Joint Degenerative Diseases, okay? It's a bit different from what you see on the tentative, which is bone degenerative diseases, but I'm tired of talking about bone, so I want to change to join this round. So, first reader of the day. Why are there 3 donkeys on my cover slides? I will let you know the answer, you pay attention later. First thing on osteoarthritis. Osteoarthritis is a disease of cartilage degradations, joint swelling, pain, and stiffness. It affects the patient's mobility and also quality of life. According to a latest Global Burden of Disease study in 2021, you can see an increase in the patients of osteoarthritis. In terms of prevalence incidence, I hope the medical students is aware of the difference between the word prevalence and incidence. And also, in terms of burden of the disease, measured in life lived with the disease, there is also an increase. Unfortunately, for the ladies in the hall, osteoarthritis is actually a sex-dependent disease whereby post-menopause, you will see a drastic increase in the numbers of post-menopausal women suffering from osteoarthritis compared to their male counterpart. However, all of these are just textbook informations. All of these are just numbers. Think of your parents, think of your grandparents, and your loved ones surrounding you who have family members of seniors in the family suffering from osteoarthritis. Can you raise your hands? Okay, a lot of us have, including my mothers, including my PhD mentors. Okay, so you as a doctor, wouldn't you want to try to help your loved one, your family members who are suffering from this disease? So this is one of my main drivers to conduct this osteoarthritis research. When we think about osteoarthritis, we seldom associate it with inflammatory conditions. However, osteoarthritis is indeed inflammation localized at the joint compartment. After suffering from mechanical injury, the particle released from the cartilage will elicit inflammations on the synovial cells, which release inflammatory cytokines. These inflammatory cytokines will trigger the expressions of metalloproteinases for the chondrocyte. And these metalloproteinases will trigger further degradations of the cartilage. These form a vicious cycle which propagate the joint destructions. Also, I don't know why the animation is not working, but anyway, osteoarthritis, we often think it as a joint destruction disease. However, it is not just the cartilage which is affected. It is also the subchondral bone, which is the bone beneath the cartilage layer. At the early stage of the disease, you will see a decrease in the thickness of subchondral bone. At the late stage, after the cartilage layer is being destroyed, the subchondral bone has to bear most of the mechanical loading of the joint, and it becomes thickened. In terms of pharmacological intervention for OA, usually doctors use analgesic, including NSAID, to relieve the pain of the patients. However, NSAID, as you know from your basic pharmacology, is associated with certain side effects. We also use intra-articular glucocorticoid to suppress the pain and inflammations at the joint. However, prolonged use of glucocorticoid is known to destroy joint and cartilage further. We also use intra-articular hyaluronic acid to increase the lubrications of the joint. However, the effect is only transient and we require repeated injections. Lastly, we also have slow-acting disease-modifying anti-osteoarthritic agents, for example, glucosamine and chondroitin. They provide building blocks of the cartilage. However, their long-term efficacy is doubtful. And some of you might know, glucosamine are derived from seafood. And those with seafood allergy might not be able to tolerate these medications. So we can see that there is still a demand for joint protecting agents, and there's a lot of space for research as well. In our lab, we model osteoarthritis using intraarticular injections monosodium iodoacetate. In short, I call it MIA because it's too long, okay? So intraarticular injection of MIA, which is a glycolysis inhibitor, it can actually, as you can see, after injections, the staining of the cartilage become faint. This is because the proteoglycan content on the cartilage layer is being reduced. We also observe that at the subchondral bone layer, the osteoclast number increases. On cell culture plate, using doses of MIA which did not cause apoptosis of the cell, we realized that MIA can induce a lot of oxidative stress in the chondrocyte. However, for the inflammatory cytokine, it actually decreases the inflammatory cytokine expressions on the chondrocyte, probably because the chondrocyte has gone through senescence. It's not able to undergo physiological functions, for example, undergoing inflammation anymore. So this is the first product of investigations that we are interested in, tocotrienol, which actually is a foundation basis of our research group. Tocotrienol, although the name sounds complicated, you might recognize it using another name, vitamin E. Okay? There are two groups of vitamin E, tocopherol and tocotrienol. I'm not sure whether the people at the back can see the differences in the structure or not. You will realize that tocotrienol had 3 double bonds compared to tocopherol at the long carbon tail. And these 3 double bonds allow tocotrienol to perform many functions that tocopherol cannot do. Okay? And each group can be further divided into alpha, beta, gamma, and delta isomers depending on the material change on the chromanol ring, the ring at the front of this, at the head of this molecule. Usually in natural resources, tocotrienol and tocopherol exist in a mixture. These are the 3 major sources of tocotrienol in the nature. We have rice bran, palm oil. Okay, these 2 we have in Malaysia and also Indonesia. We also have annatto. Okay, you might not be very familiar with annatto bean. Okay, it looks like rambutan, but it's not. Okay, annatto bean is widely cultivated in South America. It is being used to color cheese because the seed itself contains red-orange pigment, which make the cheese orange. However, annatto bean do have a unique composition of vitamin E, whereby in nature it doesn't contain any tocopherol, in contrast to palm oil derived tocotrienol and also rice bran derived vitamin E, which have a certain percentage of tocopherol. So the biological effect of tocotrienol has been widely studied. We are not the unique group who study the biological effect of tocotrienol. These are all the effects that has been studied, and we, our research group, are concerned about the musculoskeletal effect. And these are some of the papers, recent papers were published regarding the effect of tocotrienol in combating osteoporosis. So these are some of the postulation mechanisms how tocotrienol can prevent osteoporosis through the inhibition of oxidative stress, the inhibitions of inflammations, and also the inhibitions of HMG-CoA reductase activity, which are important in the cholesterol pathway. We have also performed some preliminary studies on osteoarthritis, okay, by using anatotocotrienol and also palm-tocotrienol. And we contrast their effect with glucosamine sulfate. This study was performed in male rats. I don't know why one sentence is missing there. In these studies, we use MIA to induce osteoarthritis first, and then within a week, we supplement it with tocotrienol. Okay, so this is sort of secondary prevention. If you're talking about public health, the disease just initiated, and then we start supplementations to prevent the disease from progressing further. All these studies are performed in male rats. So during the correspondence between us and the peer reviewer, we often encounter one very important comment. Why don't you use female rats? Because not many male, in relationship to postmenopausal women, not many male have osteoarthritis. Okay? So the model that we are using does not represent the most affected population of osteoarthritis, which is the postmenopausal women. So in our further studies, this picture is not correct, but I don't know why it's shown here. But using this model, we try to validate the effect of emulsified palm-tocotrienol on optimized rats with OA. In this study, we use a unique approach whereby supplementations occur immediately after orectomy, and then we induce osteoarthritis, and then we continue supplementation for another 6 weeks. During the supplementation period, the grip strength and also joint width of the rats are measured, because you know that as osteoarthritic patients, your joint functions decrease, and also you have swelling of the joint, so we measure the joint width. And then we also measure scientific markers of cartilage degradations, which is named by abbreviation COMP. Okay? We also harvest the joint of the rats, and then we do sections of the cartilage and stain using safranin O staining. We will stain the proteoglycan content pink, and also the subchondral bone. We use a conventional bone histomorphometry method to stain to analyze the subchondral bone. So again, because animation is not working here, so you might feel a bit confused. Okay. So first thing, we talk about the effect of joint with grip strength and also serum markers, which is COMP. Firstly, you look at the blue box. Okay. The blue box shows that with the induction of osteoarthritis, you see an increment in joint width. Okay. And also you see a decrease in grip strength as measured by when the rats release the front paw and when does the rats release the hind limb. Okay? Because when we do the inverted mesh wire test, the rats always release the front limb first and then the hind limb. Okay? You also notice that with time, the serum COMP level actually decreases with time in the sham group. However, this kind of decrease does not exist in the negative control group. Now you look at the red box. With the supplementations of positive control, which is glucosamine sulfate, and also tocotrienol, emulsified and non-emulsified, you see reductions of joint width compared to negative control at the same time point, and also improvement, especially in the emulsified tocotrienol, in terms of grip strength, and there's also a decrease in the circulating COMP level. This is a histological slice on the cartilage, stained using safranin O stain. You can see that with OA, the cartilage can be seen completely gone. However, with the supplementations of glucosamine sulfate and also tocotrienol, both versions, you see the cartilage layer is being preserved. And all this is quantified using Mencken score by a blinded histologist to alleviate bias in research, and this is proven using the score, subscores and total score. Then we look further into the subchondral bone histomorphometry, which is a layer
a bone beneath the cartilage. So Prof. Rama will feel a bit nostalgia about this kind of staining because this is what she do all days in her PhD lab. Okay? So firstly, you can look at the black and white panels. In the black and white panels, we stain the bone using silver nitrate. So it binds with the phosphate elements in the bone. Okay? Then we visualize how much bone we have in that tissues. We see that although we don't see a significant difference between the OA group and non-OA group, the supplementations of tocotrienol did increases the bone volume, trabecular number, and it decreases the trabecular separations. Okay? And then we look at the dark panel. The screen is not very clear here, but there are faint green line in this dark field. Okay? This faint green line is actually calcium staining. The calcium is deposited into the bone tissue when bone remodeling occurs, or bone formation occurs. By quantifying the green faint line, we can establish that there are actually increased bone formations in the tocotrienol group. Lastly, to the Hessian staining, you're all familiar with Hessian staining, we can see that with osteoarthritis, there's a significant increase in osteoclast numbers, meaning that there is occurrence of subchondral bone sclerosis, okay, at this stage. And with tocotrienol, you see there's a decrease in osteoclast number and also a significant increase in osteoid number, meaning that a lot of matrix being deposited onto the bone. So as a conclusion, our INVO study showed that palm tocotrienol supplementation for actually 10 weeks, not 6 weeks, prevent joint swelling, improve bone strength, preserve cartilage integrity, and also subchondral bone in autotomized rats. And emulsification allow us to use tocotrienol at a lower concentration to achieve effect at a higher concentration in the non-emulsified versions. And you can read our report further in this article. So at this stage, you might be interested, how did tocotrienol achieve the effect on the joint? So we did in vitro studies whereby we exposed SW1353 chondrocyte concurrently using MIA and also anatole palm tocotrienol for 24 hours, and we look at the survivability, oxy stress, and also chondrocyte health markers. Okay, these are some of the things that will be proteins that will be synthesized or expressed by chondrocyte during its maturations. Okay, and aggrecan is a marker we use as an anabolic effect of the joint, and ADAMTS4 we use as a metalloproteinase. It is a catabolic markers of the chondrocyte. So we do have a very complex graph here. No worries, you just listen to me. You don't have to look at the graph. Okay. First thing. Okay. With the supplementations of tocotrienol, either from palm and anatole, there is a suppression of the oxy stress as marked by the 8-isoprosan level, which is a stable lipid peroxidation product. Okay? So anatole and palm tocotrienol reduce oxy stress in chondrocyte exposed to MIA. That is okay. Then we observe something very interesting. With anatole tocotrienol, when it is supplemented in conjunction with MIA exposure, it significantly promoted all the markers of chondrocytic health. Okay? It sort of pushed the chondrocyte to survive during an assault. However, this effect is not seen when MIA is not there. Okay? This promotion effect only is seen when there is an assault. Okay? When MIA is not there, then anatole don't do anything. You just go on with a life as usual. This effect is also not seen with palm tocotrienol, with or without MIA. Okay? So this is a unique property of anatole tocotrienol. So our in vitro study shows that both anatole and palm tocotrienol can preserve chondrocyte viability and reduce lipid peroxidation in the presence of MIA, which is a form of assault to the chondrocyte. However, only anatomical triangle stimulate chondrocyte repair in the presence of a site which is MIA, but palm tocotrienol does not. And we postulated that differences in the vitamin isomers composition between these two mixtures could be responsible for the distinct actions. And in future, we are hoping we can trace upwards what other similar pathway involved. But for the pre-preliminary studies, it is published in this article. If you are interested, you can have a read. Then we move on to our second product by the Chinese name Yijiao. Chinese name we call it Jiao, but then to translate to English we call it Yijiao. And remember the 3 donkeys on my cover slides? The 3 donkeys are here. They are made using the donkey skin gelatin. Okay, we harvest the donkey skin, we stew and stew and stew, it become very concentrated, and then we make it like a chocolate bar. No sugar added. Okay, so this kind of the Yijiao is being used traditionally by Chinese people to enhance blood formations, especially in women, and this effect has been proven scientifically. Okay, it can promote the differentiation of hematopoietic stem cell. Okay, and it contains a mixture of amino acid and peptide, and especially glucosaminoglycan. Where do you find glucosaminoglycan in your body? The medical students are shaking their head. Your cartilage. You find a lot of them in your cartilage. Okay? And this form basis why we'll be interested in investigating effect of Yijiao on joint. Okay? And they also have a lot of volatile compound and trace elements. And one benefit of Yijiao, it doesn't expire. The longer it keeps, the effect is better. Okay? So we have conducted previously a lot of studies on the skeletal effect of Yijiao. Okay? And we have shown that Yijiao actually prevent high bone remodeling phenotype usually you've seen with estrogen deficiency, so it can prevent bone loss. At the same time, we also observed that Yijiao can prevent bone marrow adiposity. Okay, it can prevent the formations of adipocyte in your bone marrow. It also decreases oxidative stress at your bone marrow. Why does prevention of adipocyte formation in your bone marrow important? Okay. So medical students, if you have studied your embryology, you must be aware that adipocyte and osteoblasts comes from the same lineage of stem cell, which are mesenchymal stem cell. If you have a lot of adipocyte forming in bone marrow, there won't be enough reserve of stem cell to be differentiated into osteoblasts. Okay, so that becomes a risk factor for osteoporosis. So in these instances, we also studied the effect of Yijiao on joint in an optimized model with MI-induced OA, okay, whereby all rats are optimized and we rested them for 4 weeks to deplete the estrogens, and then we use MIA to induce osteoarthritis treatment for 5 weeks. During these 5 weeks, we measured their joint width and grip strength, and then they are sacrificed, their right femoral joint affected by the osteoarthritis would be section for histology, and the tibia part of the cartilage, we will homogenize it, and then we test using RT-PCR and Western blot for certain markers. So this is how we conducted the test. So the image below is an inverted mesh wire test. Very simple tool, very simple tool, but recognized. My PhD student husband actually built me this tool. Okay, so basically you let the rats hold on the inverted mesh wire and you invert the mesh wire, and then you wait for 2 minutes to see how long it falls down. Okay, so we look at the percentage improvement on joint width, joint diameter. We see the OA group have not treated has the least degree of improvement. However, with the high dose Yijiao, you see a significant improvement of the joint width compared to the initial stage where osteoarthritis is just induced. And then with the grip strength, we see with the treatment, there are significant improvement in grip strength over the course of 5 weeks. This is a joint structure stain using safran O stain. Again, this is being scored by a blinded histologist to alleviate bias. We can see that in each subdomain of Mencken score and total score, with OA, there's a significant increase in the score. However, with medium dose E-gel, you see a decrease in the Mencken score. This is a subchondral bone structure using mucosa staining. You don't see a significant differences between OA and non-OA. However, with low dose and also high dose E-gel, you see a significant improvement in bone volume, trabecular number, and also a reduction in trabecular separations. This is again the calcium staining, okay? This is more clear, I hope. With OA and non-OA, you don't see a significant increases. However, with low dose E-gel, you see a significant improvement in mineral opposition rate, meaning that there are more calcium being deposited on the bone surface. Then come an interesting result, okay? We actually analyzed the cytokine and also metalloproteinase expressions on the cartilage layer. We are hoping that with OA, there will be increased inflammations, increase in metalloproteinases. However, with OA inductions in MIA, there isn't. And more surprisingly, we saw a significant decreases in I1 beta and also MMP9 and 13 in the MOA control. So what happened? Do you remember my cellular studies? I said that with MIA, chondrocytes undergo cellular senescence. They are not able to perform the usual cellular functions. They cannot even synthesize MMP anymore. They cannot even synthesize inflammation markers anymore. They are so damaged. However, with the supplementation of E-gel, you can see that their cellular function actually revert to the level of that of sham. Okay? So senescence degree in the supplement group is not that severe and it still can perform the usual inflammation functions. And then we also tested the WNT signaling markers for the chondrocyte, the sample harvested from the cartilage. With OA and non-OA, you don't see a significant differences. However, with medium dose E-gel, we see an inhibition of the WNT signaling pathway characterized by the ratio of phosphorylated beta-catenin versus total beta-catenin. When beta-catenin, a transcription factor, is being phosphorylated, it will be degraded. It cannot enter the nucleus to do transcription functions. So what does it mean? So activation of WNT pathway is required for chondrocyte hypertrophy and senescence, osteophyte formations, and inflammations. The WNT signaling doesn't seem to be activated in OA control because the MIA was only injected one time. And across the 5 weeks, the OA might be resolving at time of sample collections. But medium dose E-gel inhibited WNT signaling pathway by promoting phosphorylation beta-catenin. It correlates well with the phenotypic changes for E-gel supplementations, whereby you see less disease progressions at the medium dose E-gel. So overall, we can postulate that the supplementation of E-gel actually inhibited the WNT signaling pathway, thus chondrocytes do not undergo hypertrophy and senescence, and you don't see fibrotic changes at the joint, and the cartilage layer is preserved. When cartilage layer is preserved, the subchondral bone will undergo less mechanical loading. It doesn't undergo sclerosis. This is how E-gel protected our joint. So just a repetition, medium dose E-gel can prevent joint swelling, cartilage degradation, and subchondral bone integrity in orthodox rats with OA, and this suggests potential beneficial effect to post-menopausal women with OA. It might also prevent cartilage fibrosis associated with chronic OA, but this await further validations. And the effect of E-gel might be mediated by WNT signaling, but this again await further validations. So these are the two products I'd like to introduce you today. There are more than one type of joint degenerative diseases. Apart from osteoarthritis, we also have intervertebral disc degenerations, but we are not touching that today. Okay? So I'm just showing all these studies to illustrate to you the scientific process, okay, and some interesting things we are doing. I was doing sarcodrome for with osteoarthritis for not too long. So we'd like to thank Ministry of Education Malaysia for funding our study and also UCAN for funding our studies. I would thank the collaboration for UCAN collaborators, my students who are doing all the work. You can see that we have a very diverse team. For Africa, we have local Chinese from Iraq, from local Malay, local Chinese, local Singh. My postdoc is Nigerian, so we have a very diverse group, okay? And we hope that maybe someday you'll be interested to join as part of a group as well. We also thank our external collaborators, for example, Zhejiang University for giving us the e-gel, and also the suppliers of tocotrienol in Malaysia who give us tocotrienol use in this study, and also my department members who are doing the technical work, okay? So lastly, just give me 3 seconds for advertising. I'm currently the editor-in-chief from the International Health UKM. So it is a ESCI index journal, so consider WOS, okay, Q4, and we welcome you to submit to our journal, okay? That's all, thank you.
Thank you, Dr. Chin. Applause for Dr. Chin. Thank you for insightful presentation. And next, it is my pleasure to introduce the second speaker, Dr. Pang Kok Lun from Monash University, Malaysia, who will deliver his keynote entitled Natural Product as Adjuvant Therapy Candidate for Chondrosarcoma. Maybe for his curriculum vitae, Dr. Pang Kok Lun, Bachelor of Biomedical Science with honor in UKM 2011, and he have 33 publication with 16 papers, and 2 years research experience in medical and lab science, and 2 active research grant SPI. For Dr. Pang Kok Lun, time is yours. Maybe online.
Yes, testing. Can you hear me?
Yes.
Yeah,
yes, Dr. Pang Lun.
Introduction. So allow me to share my screen. Okay, hope you all can see my screen. Okay, so thank you very much for the committee member for this invitation. I'm Pang from Monash University, Malaysia, under the School of Medicine. So previously, I'm under postdoctoral fellowship under the supervision of Associate Professor Dr. Gabriel, just now the speakers, and part of today's sharings, the findings will be under this postdoc fellowship. Okay, so for today's title for our sharing section will be on natural product as an adjuvant therapy candidates for chondrosarcoma. So for your information, chondrosarcoma is the second most common primary bone cancer, and to be honest, it's not really common, it's quite rare, and whereby the primary onset will affect the cartilage cells over the proximal femur bones, pelvic, shoulder, or ribs. Okay, so this kind of a cancer is a kind of unique. Interesting in the way whereby they are naturally resistant to chemotherapy. So those chemotherapy agents, including the radiotherapy, not really effective in chondrosarcoma. So the mainstream kind of treatment usually we go through surgical removal. So they're going to remove it, and potentially sometimes depends on the stages of this kind of the bone cancer, and clinicians or doctor may combine together with some others adjuvant therapy like radiotherapy, even though it's not really effective. So hereby we are thinking of any kind of the alternative strategy and can kill this kind of cancerous cells or induce cancerous cell death in another way or another kind of strategy. So here again tocotrienol. So this is the natural product as just now Associate Professor Dr. Chin has introduced to you. Is part of the what they call the example, okay, the natural type of the vitamin E, having the 4 different isoforms based on the different side chains over the chromatography. And of course, tocotrienol, they have the unique hydrocarbon chain whereby it is polyunsaturated. Okay, so here I'm not focusing on the musculoskeletal disease and things like that, but more towards the musculoskeletal cancer, bone cancer as example. And based on the previous study, among these 4 isoforms, gamma and delta tocotrienol, they are more potent in the sense that they are more successfully in terms of like killing or eliminating those cancer cells, okay, including those from the breast, from the lung cancer, etc. So here again, aside of the pure isoforms, we also think of one of the unique source of the tocotrienol. As just now Dr. Chin had mentioned, we have the rice bran, we have the palm oil, and here we have the anantho tocotrienol from the South America sources. This is a unique, interesting kind of the tocotrienol source of extract, whereby it contains only alpha and delta tocotrienol. So of course the compositions depends by the batch to batch variations. So roughly 84 to 90% of delta tocotrienol and around 15 to 10% of this gamma tocotrienol. So over here we are kind of having this kind of our research question whether this can be a potential target regardless the anantho tocotrienol. In short, we call this as ANTT, including the 2 more potent isoforms, gamma and delta. How is it, whether it works or it can work in a different kind of the mechanism in causing the control sarcoma cell death. So here for our experimental design, we are of course using the ANTT that contain the mixture of gamma and delta tocotrienol, including the pure isoform of the gamma and delta tocotrienol, are using T3 as a short form. And then we undergo several assessments, including the cytotoxicity, how it kills the cancerous cells, in this case the control sarcoma, proliferation, how it suppress or having this anti-proliferative effect, so it may not execute the cell death, but somehow it suppress the cell to grow faster. Okay. Aside of that, as a projection from the cytotoxicity, we know the cell death is occur, but we want to understand what kind of the mode of the cell death, in general speaking. So we are going using the here we was using the apoptosis assays, and then it can differentiate whether the cell is dying through apoptosis, a programmed cell death, or through the cell burst, cell lesions, and then what they call the necrosis kind of the event. Okay. Besides of that, we also examine the DNA content, whereby it will identify the different cell cycle phase, okay, the interface like G1 phase, S phase, G2M, and etc. And then we also extract the total RNA from the cells, and then we perform the transcriptomic analysis, okay, using Illumina high-seq X sequencing. So after that, we'll perform the data analysis. So let me show you what we have from this project. So as expected, despite this is the very first demonstration on control sarcoma, we're using human control sarcoma SW1353 cells. And based on our observations, delta topotrienol sorry, appear in the blue color curve, okay, appear more cytotoxic, okay, more potent compared to the two variants, including the middle's orange color indicated by ANTT, and the green color which is gamma tocotrienol. Okay, they have their respective IC50 upon 24 hours treatment, which is 19.5, 28.5, and also 38.5. Okay, so kind of like expected as ananto tocotrienol ANTT that have the mixture right between the gamma and also the delta, so it is still lay in the between. So from using this IC50, and then we continue with the apoptosis assay, and then from here we are going to using two biomarker. First will be the IDMI signals. So when the cells undergoing the apoptosis, they will express the apoptotic marker over the cell surface. So in the layman we call as an IDMI signal, whereby they attract the phagocyte, the wiper cell come over to do the engulfment. So they'll engulf, they'll eat them, and then they'll digest of them. So in specific, this apoptotic marker, they are the phosphatidylserine, okay, one of the hydrocarbon tail over the cell membrane. So usually we know that phospholipid bilayer of our cell membrane that have the hydrophilic group, and then followed by two hydrophobic tail. So these two hydrophobic tail, they are considered this phosphatidylserine. So in the normal condition, they will be hiding inside this phospholipid bilayer. So when the cells is undergoing apoptosis, so somehow they will be executed by the enzymes, and as this is under the program cell death, and then the enzyme will be having this flip base and also the flock base. They're going to outflip, externalize this phosphatidylserine, the hydrophobic hydrocarbon tail towards the extracellular matrix. Okay, so we're going to using these kind of features, and then we're using NSN5 reagent, whereby this NSN5 reagent will bind to this IDMI signal. Okay, of course, NSN5 itself, it doesn't have any color, doesn't have any signal. So usually from the commercial, we're using the NSN5 that conjugate together with the fluorescent dye, which is like can be the fluorochrome C or FIC, okay, we call that as a FIC. So here back to our result we have, interestingly it doesn't really show any significant cell death, as you can see for the VC, which is the vehicle control, the untreated control here. They will be around 90% of viable, so means that they are negative with the NSN5, they are negative with the PI, whereby PI only will penetrate and go into the cells to bind with the DNA when the membrane integrity is being compromised. Okay, in other words, when the membrane having the pore was ruptured, then PI can go across the membrane and bind with the DNA and give the red color of signal. Okay, red fluorescence of the signal. And back to the finding we have upon treatment with IC50, we get from the MTT assay. Okay, none of these tocotrienol show any significant kind of the cell death. So more or less, in terms of the healthy cells, surviving cell, the percentage is roughly the same. The percentage of apoptosis is similar to the baseline, and almost none for the necrotic population. So here this triggers some kind of a question, what is going on here? So we have using the IC50, whereby the IC50 from MTT assay, it shows that there will be a reduction in terms of the cell viability. But how comes when we perform the apoptosis assay and it show up this kind of negative findings? So first thing first, we understand that MTT assay and also NSN5 PI assay, they are different. They are measuring two different endpoints. So based on the MTT assay, as you understand, they are rely on the conversion of this MDD dye by the mitochondrial dehydrogenase that found as a complex tree inside the mitochondria, organelle, and then they'll convert into the formazan and then produce a color after we dissolve with DMSO or other solvent. Okay, so this kind of the mitochondrial dehydrogenase activity will be affected by the quantity of the mitochondria, or in other words, the quantity of the cells. Well, back to the NSN5PI, as you know, they are depending on the externalization of the phosphatidylserine, the immune signal, and also the membrane integrity. Is it the membrane become porous, having the been tear off, and only the PI will coming in. So here we have some kind of the postulation, okay, whereby from the NSN5PI we found that the cells are surviving. However, if we combine with the MTT-assay with that particular concentration of IC50, the cells are not proliferating. Okay, so means that after 24 hours, the untreated control somehow they manage to double up their numbers twice as much as these compared to the treated cells. Okay, that shows the difference in terms of the color intensity from the MTT, and that translates into the IC50. Okay, so to confirm our postulations, I will show later on. We'll proceed with the proliferation assay, cell cycle analysis, and also prolong the treatment. So here, when the cells having some kind of a damage, assault, or any kind of lesions, so first thing first, the cell will try to repair. So regardless of normal cells or cancerous cells, all the cells will try to survive. So they'll try to repair. So when they're doing a repair under the normal mechanism is that they're going to stop the cell from proliferating. Then they'll activate those DNA repair enzymes, some kind of enzyme, they do the repair work. After that, when the repair is completed, successful, then they'll restart back the what they call the cell cycle or the proliferation. So what we postulate is that upon the tocotrienol treatments, regardless of NDT, gamma or delta tocotrienol, they do something, okay, they did something on the cells. Can be the organelle, can be the DNA, okay, we still don't know at this moment. And that requires the cell to stop from proliferating, and then they focus on repair. Okay, hope you all got it. So from here, we'll perform first the anti-proliferative assay, or we call this as a modified MTT assay. So what we, how we did this thing different is that from the conventional MTT, whereby we using a much lower cells concentrations, only like 1 × 10 power of 3 cells per ml, okay, very low. And then we let the cell to grow after like 3 days. So of course, we have comparisons like in different concentrations of ananto tocotrienols, gamma, and also delta tocotrienol. And then from this, we found that yes, somehow, okay, these 3 different tocotrienol, they manage to arrest, okay, stop the cell to proliferate. As you can see, there will be a reduction. Okay, so if the mode of action of these tocotrienol, they are purely like execute the cell there, eventually they'll all just gone, they won't proliferate. So cells still will proliferate, but they are proliferate much more slower from this modified MTT assay. To really confirm our postulation, we further perform this cell cycle analysis as mentioned in the experimental design. And then we're using the piRNA staining buffer to stain the DNA after we fix the cells with or without the treatment. So we see this is untreated vehicle control cells, and then we can see the first peak. This is the 2N of the genetic content, and then along the way they're having the synthesis phase, and then until the second peak here will be the G2N phase, which is the tetraplot. Okay, 4N of the chromosome. So from here, when we put with the PI stain will the intensity of the fluorescent signal will be directly proportional to the quantity of the DNA. So when they have just 2 sets of the chromosome or the DNA, they'll give this signal. So once they go through the DNA synthesis phase, they're having the 4 sets of the chromosome, then they'll be double up the signal. Okay, as simple as that. So by checking on this, and we'll notice that upon this NTT, gamma, and also delta tocotrienol, maybe from here not really showing a very clear difference. But as you can see here, the population for the G2 will be reduced a bit, and then the S phase here also will be lower than the usual. I mean, compared to the VC, the untreated control. And of course, I'm going to show you the quantitative data. So we also performed a much earlier time frame and also 24 hours time frame. So from here you see that upon 24 hours of treatment, ananto, tocotrienol, gamma, and also delta tocotrienol, they managed to further increase 5 to 10% population of the cells that arrest over the G1. Okay, while for S phase you'll reduce, some even the G2 phase also will be reduced. So even though this is like just about 5 to 10% of the cells, we found that they are arrest in the G1. Okay, again, the percentage of the cells they found arrest doesn't really directly translate into the total quantity. Okay, they are not a linear kind of relationship. So despite here we identify only 5 to 10% of the cells, they are more in the G1 cell cycle phase, and that already translate into like 50% reduction in terms of the cell proliferation. Okay. Okay, next, to further confirm our postulations, the cells need to, when they receive or having some kind of damage, okay, due to the tocotrienol treatments, and then the cell try to survive, they'll try to repair. After that, when they manage to repair, then they will, they'll back to the normal and then continue to cell proliferate. So what if, let's say, we using that particular IC50, okay, for NTT tocotrienols, for gamma and also delta tocotrienol, and then we prolong the treatment from 24 hours to 40 hours. So initially, okay, the cells will try to repair if they, and then they're having the cell cycle arrest. If they're not able to repair it, then they will subject to cell death. So as parallel with our postulations, when we further prolong this to the 48 hours, and then we can see the cell viability start to drop. Okay, start to drop it down significantly compared to the vehicle control. And then the green color noted as the apoptotic cells, the percentage of the apoptotic cells also be increased. Like for ananto tocotrienol, here you cost about 50% of the cells undergoing this apoptosis. For gamma, we'll be having this like nearly 70%. For delta, probably just around 20-30%. Okay, and again, this is not the IC50 from 40 hours. Just that this is the IC50 from 24 hours, and we prolong it until 40 hours. So here we're going to show you some images, not all. Okay, of course we do have 12 hours, 24 hours, and etc. But here just want to show you the 48 hours treatments before we proceed to the apoptosis assay and things like that. We do capture it. Okay, so we capture the images. So these are the vehicle control cells. They contain those solvents, and then you can see that this is their normal. Not to say normal, the typical morphology for these control sarcoma cells, okay? They're kind of like having a link up, and then not really, not to say totally spindle in the shape, but somewhere in between, in the mix, okay? Not fully epithelial, not fully fibroblastic in kind of morphology, okay? Upon treatments, okay, let's go to the gamma tocotrienol. With their IC50, you can see the shape totally different, okay? It become like shortens. Definitely the cell density, the cell number is lesser compared to the vehicle control. The cell also, in terms of irregular, in terms of the shape, okay, become like hexagonals. Some will become spindle in shape, and then some even like round up, dying. And then the interesting part is that if you can see into more details inside the cells, you can see all these white color vesicles. Okay, white color vesicles. So before treatment, maybe on and off, they might have one or two, not all. But after treatment, they become more prominent. Okay, so something interesting later we'll talk about that again. How about for delta tocotrienol? So most of it, okay, definitely the cell number is reduced. not as dense as the vehicle control, but most of it, they still roughly maintain the general populations, typical the morphology for the cells. And on and off, some cells will become like elongated, spindle in shape, and they do have some kind of the vacuole formation as well. And for Anando tocotrienol, somehow expected the things are lay in the between. It did reduce the cell density, okay, and then they also alter the cell morphology, becomes like hexagonal or squamous kind of morphology, and then they do have the presence of the vesicles. As you can see from the arrowhead, okay, all these white color round up shape that present inside the cells, okay, after the treatment. Okay, so from here we found that, okay, in this 24 hours ICT, the Anando tocotrienols, gamma and delta tocotrienols, they did induce cell cycle arrest, G1 arrest to be precise, and then they do affect some kind of the morphological changes as we discussed earlier on. So next, we want to identify what is happening, okay, what kind of the underlying mechanisms being performed, and then there is too much of the pathway we can target, from the AKT mechanism until the others, oncogenic, MYC and things like that. So here we take this transcriptomic approach. We're using the transcriptomes profiling. We will extract all the total RNAs from the cells, okay, by using the Mayjen RNase easy kit. And after that, we make sure the RNA is pure with the good absorbance of 260 over 230, more than 2 or equal to 2. And the RNA integrity numbers, the real number is at least it should be more than 8. Okay, so far we got the real number at least should be 8.929 and above, and then the purity are good for us to proceed with this mRNA sequencing using the Illumina Hi6X machine. So after that, we have performed all this sequencing. We have more than 1,000 over different genes. And then, of course, we have the group for the control. We have the Anando tocotrienol. We have the gamma and also the delta group. So we'll apply the standard default kind of the cutoff. Okay, we're using the adjusted p-value, or some may call this as a q-value of less than 0.05. And then the fold change by comparing Anando tocotrienols versus the control group, or respective gamma or delta tocotrienol versus to the control group. Okay, so this is a Venn diagram to show you how many genes are present, and then those they are upregulated based on our criteria. The fold change have to be more than 2. Some they are downregulated. Okay, so let me show you the next slide. So this is something that we use to do the cutoff. Okay, so only those that appear in blue color here, blue-green color, here will be considered for next stage of the analysis. After we apply the cutoff, as mentioned, q-value less than 0.05, and then the fold change more than 2. So here, fold change more than 2, or we can using the absolute value of the log based on the value of 2 over the fold change add to more than 1. Okay, it indicates the same thing, just that 1 is with the fold change more than 2 based on the absolute value, or we can using the software to just calculate the log 2. Okay, just a different calculation. They are indicating the same things. And then here, before we go to the result analysis, and then just show you that this is the cluster of the genes expression that we have. And this is a typical heat map. And then different color indicate we have 3 biological replicates for Anando tocotrienols, gamma and delta tocotrienol, including the vehicle control group, okay, as labeled with the respective name. A will be ANPT, D will be the delta tocotrienol, G will be the gamma tocotrienol, and V will be the vehicle control group. Okay, so from here you can see they indicate by different colors. So some red color means highly expressed, the blue color means that they'll be downregulated. So you can see that they have 2 different kinds of profile, okay, upon the treatments. So we'll go into the next to show you what we identify. So, because of the time constraint, I not really go through all the analysis. I'll just emphasize on the KGG pathway analysis that will be conducted by using the R package and also using the DARI. So I will show you later on. So based on the Q value, we rank up what are the those gene lists. They are upregulated, okay, based on our criteria. So of course, smaller the Q value means they are more significant. And then we're going to plug in all these genes being upregulated into the R package, and then they'll identify, they'll cluster all these genes, like which kind of a gene they are under the cell cycle, which kind of a gene they are under the cell death, which kind of gene are under the other kind of mitochondrial pathway and things like that. Okay, so here, of course, we show is more than 10, okay, more than 10 all these upregulated pathway based on this our approach. And then you can see that the size, the circle size indicate how many quantity of the genes they are in this category. So bigger means that they involve a lot of the gene. Okay, means they are more significant. Second will be on the Q value or adjusted P value. So let's say they are darker in terms of the red color. If you can notice the red color, means they are more significant. Okay, so based on these two criteria as mentioned earlier, so we are ranked up, and then as usual, if you are involved with genomic or microarray, including this RNA sequencing or the transcriptomic, sometimes we will encounter some others unrelated pathway being show up, okay, which is totally normal and very common. So how are you going to identify whether this is relevant or not relevant? We have to compare together with our previous study. Okay. So from here, those that sounds interesting or relevant to our current findings. First in the list will be the protein processing in the endoplasmic reticulum. It shows that all this activity is increasing. In other words, it indicates that there is an endoplasmic reticulum stress, and then the cells try to compensate it, okay? The rest will be more towards the autophagy, whereby this is our another future direction. We're going to identify further venture on it. And then the rest like neurodegeneration, ALS, herpes simplex or viral infection is not really relevant. So we not really further discuss on that. And then another things that we found kind of interesting will be the protein export, and also the snail interaction in the vesicle or vesicular transport may somehow explain with our morphology analysis the presence of the cytoplasmic reticulum upon the treatment. Okay, next we have this, in fact more than 10 now, okay, all the down-regulated signaling pathway that happens upon the tocotrienol treatment. So the similar criteria being employed here. So bigger the circles means they will be involved for more different cluster of the gene, and then darker the red color means that is highly significant in terms of the adjusted P value or the Q value. Okay, so as similar as you can see, there will be involvement of SLE, alcoholism, or some kind of the neutrophil entrapments, whereby that is not really relevant to our cancer study here. So I'm going to highlight several pathways being downregulated upon the tocotrienol treatments, including the cell cycles, all the processing. Okay, so all the processing protein enzymes being downregulated. Indirectly, it translates and indicates that the cells is having cell cycle arrest. They couldn't proceed to the next phases. Okay. So the rest will be including those cancers or cancer biology signaling pathway that involve in the cell proliferations, involved with the what else, the drug resistance and things like that. So those already been downregulated upon the tocotrienol treatments. Okay, including those you can recall on this, the TGF-beta, WNT, and also the AKT pathway as well. So here there will be another indication on here the pathway.
I'm sorry, Dr. Pangkoklun. time is finished. Maybe be continued in the end session by question and answer.
Okay, then I just stop the sharing. Thank you very much.
Yes. Next, it is my pleasure. Give applause for Dr. Pangkok Lun. Okay, for the short speaker is Dr. Razif bin Dasiman from University Technology Mara, Malaysia. His topic is the protective role of procyanidin C1 in bisphenol-induced mitochondrial and cytoskeletal damage. Applause for Dr. Razif. Okay, Dr. Razif, time is yours.
Okay.
Maybe I'm sorry. I will read CV from Dr. Razif. Dr. Razif is from University Technology Mara, Malaysia, and enthusiastic and highly motivated in academician, researcher, and innovator with a proven track record, strong leadership and communication skill, and highly committed to achieve academic goals. Academically proven and with vast experience in the field, scientific and laboratory research such as productive physiology, embryology, microscopy, and natural product, and education history 2018 and 2023 got Doctor Physiology in University Technology Mara, and this is the publication, Masya Allah. Maybe to Dr. Razif Dasiman, time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good morning to all of you. Okay. First of all, I would like to express my gratitude to Unisma, especially Bu Dekan, Dr. Rahma and Dr. Rio, for the opportunity given to share knowledge on this stage. Okay. Today, I'll be presenting and sharing my project on and some of the updates on the joint research grant entitled Protective Role of Procyanidin C1 in bisphenol-induced mitochondrial and cytoskeletal damage. Okay, I hope everyone here will get something from this session. Okay, inshallah. So I'm Razif Dasiman from UITM Malaysia. So I have no conflict of interest to report in relation to this presentation. Okay. Okay, these are the outlines of my presentation today. Okay, my talk will focus on the damaging effects of bisphenols on mitochondria and cytoskeleton, and on the potential protective role of PCY1. Okay, what is PCY1? I will explain after this. Okay. Okay. How are you today? Okay, let's look at this picture. All right, how are you today? Okay, so I hope everyone here is feeling happy, okay, and enthusiastic, inshallah. Okay, so my simple message is this: just be yourself, okay, because everyone else is already taken. Okay, okay, don't you agree with me? Yeah, okay. Okay, let me begin with a fundamental rule of living, a message from embryos. Okay, I love to share this picture with everyone because it is from my work during my master's degree. Okay, so the embryos actually represent us. Okay, it itself divides uniquely and completely in precision and purpose, yet it remains fragile and vulnerable to challenges that may alter its path. Okay, it needs gentle, loving and care, because in the end, its fate is the same, whether die or not, whether survive or not. Okay, so Firman Allah in Surah Az-Zumar verse 6. Okay, yakhluqukum fi butuni ummahatikum khalqan min ba'di khalqin fi zulumatin thalas. Okay, ia menciptakan kamu dalam kandungan ibu kamu secara berperingkat. As you can see the stages of embryos. Okay, dari satu kejadian ke satu kejadian dalam 3 suasana yang gelap gelita, which mean the 3 conditions are darkness in the womb, the stomach or body, and also the placenta. Okay, so then in Surah Al-Mu'minun verse 14 also describe the complete process of human creation from a drop of semen to the formation of the perfect human being. Okay, it is truly amazing, right? Okay, so for those who deeply study and understood the science within the Quran, they will love it. Okay, okay. When focusing on the early embryonic stages, these are all the potential damages in early embryonic stages. Okay, such as disintegration of spindles, hardening of zona or fracture of zona, crystallizations, nuclear damage, cellular toxicity, cytoskeletal alteration, and mitochondrial damage. And all these damages resulting in early embryonic failure and beginning of various diseases. Okay, okay. Let me share an example from my research. Okay, I studied on how extreme conditions and high concentration of chemicals damage actin, tubulin, and nuclear structure. Such damage prevents the embryos from developing and hatch. Okay, these conditions also causes mitochondrial functions or distribution to be disrupted. Okay, this is characterized by the fading color of mitochondriate as shown in the screen. Okay, so as a scientist or researcher, there are many questions that we need to answer and resolve. Okay, then we have to justify it by evidence. For example, what factors contributes to the occurrence of the phenomenon? And then by what processes or mechanisms can this outcome be explained? Okay, then how can the occurrence of this outcome be theoretically justified? Okay, okay. Let me bring up an issue about food. Okay, everyone like to eat, right? Okay, because you are what you eat. Okay, now the food itself is not the problem. Am I right? Okay, because the problem is ours. Okay, we eat according to our desires. Am I right? Okay, rather than our body needs. Okay, so have you ever caught yourself doing that? Okay, so we have to think about the condition of our food and how it packaged, how it prepared, and what ingredients are used. And all of these factors can expose us to risk, especially contaminations by toxic substances. Okay, because it is narrated in the Quran, in the Surah Al-Baqarah, verse 168. Okay, makanlah makanan yang halal dan baik, or thayyibah. Okay, kenapa? Why does it need to be good and halal? Any answer? Okay, it is because it will protect our body from diseases. It is simple, right? It will protect our body from disease. Okay, so let's move to the bisphenol issue. Okay, what is bisphenol A and where is it used? Okay, so bisphenol A is an organic synthetic compound belonging to the group of diphenylmethane, and it consists of 2 hydroxyphenyl groups. It is colorless and poorly soluble in water. Okay, just for your information, BPA is multi-purpose chemicals. It is used in the manufacturing of plastic bottles, cans, epoxy resin, thermal papers, and also in the dental sealants. Okay, and BPA is one of the EDC or endocrine disrupting chemicals. It can interfere the normal function of body and endocrine system that seem related to the development of diseases such as diabetes, chronic diseases, physiological disorder, cancer, and many more. And recently, growing number of industries use BPA analogs to change the BPA due to the restriction usage of BPA in manufacturing products and its potential health risks. So as alternative, they use BPS, BPF, BPAF, and many other analogs in the making of feeding bottles, food containers, plastic containers, toys, and many more. Okay. The question is that whether it is better than BPA, has the same adverse effect, or is more dangerous. Okay. We have to concern about it. Okay. Studies have shown that replacement of BPA with other bisphenol may cause negative impacts in various models, which is similar or even worse. Okay. So these are all the adverse effects reported by other researchers, such as reduced fertility, diabetes, neurological disorder, autism, metabolic diseases, and many more. It may be due to the potential of BPA analogs to mimic, the word is mimic, the effect of BPA. Okay, so this project focusing on BPA, BPS, BPF, and BPAF, all the BPs. Okay, okay. On top of that, procyanidin C1 was used for intervention in this study. Okay, these are various sources of procyanidin C1, such as from the pumpkin, kiwi, salad, banana, and chocolates. Okay. And these are the molecular structures of PCY1, which consists of A-type and B-type structure. In this study, we used the one which is derived from grapes, Vitis vinifera. Okay, so various findings showed that PCY1 exhibited high scavenging activities against free radicals, enhanced spermatogenesis, it has anti-metastatic activity, and many more. Kors et al. Found that PCY1 is a potent antioxidant that 20 times higher compared to vitamin C and 50 times higher compared to vitamin E. So, we use zebrafish model as a source of embryos in this study because it high fecundity, transparent embryos, rapid development, inexpensive. And then the most important thing is that their genes autologs is nearly 84% similarities compared to human. Okay, so 24 HPF embryos were used to assess, and it will be monitored after the treatment. At each, oops, how to go back? Okay. Okay, at each checkpoint, the survival, hatching, abnormalities, death, and heartbeats were recorded. Okay, for example, as you can see here, the heartbeats, okay. Okay, interestingly, okay, in this study, all PCY intervention groups demonstrated a decreasing trend in the heartbeats as compared to the analogs group. Okay, and then this is the morphological characteristic and developmental defect. You can see the, such as the defects is scoliosis, you can see the SS, and then non-detachment of tails, and many more. Okay, so this is the BPA group, BPA, BPS, BPF, and BPAF, and this is the intervention group. It is better than the analogs group. Okay, so then we move to the gene expression analysis because it was also the main interest in this study. Okay, we did an analysis of 22 genes of interest from the group of apoptotic related gene, mitochondrial energy related gene, growth related gene, cytoskeletal related gene, and oxidative stress related genes. Okay, so we also analyzed the mitochondrial distributions, okay, and ROS level using immunofluorescence staining, and the image were then observed under the confocal laser scanning microscope. Okay, okay, this is the ROS level experiment. Okay, So when we look at the apoptotic related genes, okay, BAXA, BCL2, caspase-3A, and TNFA, okay, except for TNFA, a significant decrease were observed exceeding 1-fold in the intervention group for BAXA, BCL2, and caspase-3, showing that PCY intervention protect the embryos from apoptosis. Okay, the figure showed that a possible apoptotic pathway of PCY interventions on embryos. In general, PCY intervention resulted in a decrease of ROS productions, thereby preventing the activation of stress signaling pathway, results in the reduction of apoptotic molecules. Okay, for the mitochondrial related genes, bisphenol exposure clearly demonstrated to cause mitochondrial damage, and the accumulation of ROS lead to a significant reduction of ATP. As shown in the pathway, okay, PCY intervention downregulate the expression of alpha genes, which means that PCY prevent the occurrence of more severe damage of bisphenol. Okay, and the activation of PING1 leads to the formation of phagosome to facilitate the mitophagy process. Moreover, involvement of OPA3 and MFN2 induce fusion of in both inner and outer membrane, mitochondrial membrane. Okay, and this section shows the cytoskeletal related genes, namely GRIP2A, MIDPIL, KL4, and NANOC. Okay, from this study, PCYY intervention altered the GRIP2A expression. Okay, it was also found that KLF4 were significantly increased, which means it promotes cell survival and maintains stability. And downregulation of NANOC was found, and it proved that PCYY interventions maintain structural integrity of the cytoskeleton. Okay, as shown in this pathway, the regulation of KLF4 signaling pathway and activation of ERK12 will inhibit the cell death. And the regulation of NANOC pathway also activated the to preserve the cellular integrity of cytoskeleton. And then the expression of oxidative related genes was also examined in this study. Almost all the PCY intervention groups reduced the expression of GPX1A, NRF, and SOD1, which means the production of ROS after the exposure to bisphenols hindered the PCY antioxidant function. Okay, however, SOD warrants further investigations due to their synergistic effects of BPS-PCY group, which allow protection to the embryos. Okay, this is the possible signaling pathway of oxidative stress genes. The NRF2 KIAP1 ARE pathway may explain the cellular response to ROS by the bisphenols. Okay. Then elevated ROS induce activation of various pathway which in turn activate NRF2 that initiate the activation of antioxidant genes and lead to the induction of antioxidant response. Okay. Then we move to the measurement of mitochondrial activity. Okay. The mitochondrial activity and ROS level were also measured by the confocal laser microscopy. Okay. Overall, compared to PCY, all treatment groups except for BPA-PCY displayed a significant decline in mitochondrial activity. This condition will also occurs in all PCY intervention groups that showed a trend of declining ROS level. Okay, this finding demonstrated that PCY1 has the capability to reduce ROS level in the context of, okay, this is the ROS, in the context of BPA toxicity. Okay, so as a conclusions, okay, BPA and its analog induce alteration in the morphology and development. Okay, then it exhibit genotoxic effect and induce dysregulation of specific genes. And the third one is bisphenols lead to a decrease in both mitochondrial distribution and activity. Okay, and the intervention of PCY1 possess the ability to decrease the ROS level in the setting. Okay, so before I end my session, these are some of my publications regarding the procyanidin C1. Okay. Okay, so feel free to download, read, and cite, insyaAllah. Okay, so this one, as you can see, the study of BPA, they intervene using the air kelapa, Coccus nucifera. Okay. Then we move to these publications regarding the aging. Okay. And the new one is also on aging. The role of PCY1 on aging. Okay. Then so this is also my publication on newspaper. Okay. Okay. Some updates on the grant. Okay. Thank you, Budekan, for the grant that we get on June 2025. Okay. So after a series of meetings with Dr. Rio and colleagues, okay, so the grant was registered in INDONESIA in the duration for in a period of 1 year. Okay. Then just for information, for the first step, okay, one manuscript, which is the narrative review regarding the review on the pollutant-induced inflammations, this site, okay, has been sent to BRIAC journal, which is the WOS journal, WOSQ3, and it is now in stage R2, round 2. Okay. Then another manuscript related to toxic transaction regarding the flight ticket is in draft. Okay, and both manuscripts involve collaborative writing between my team in UiTM and Unisma, which is Dr. Rio. Thank you, Dr. Rio. Okay, so with that, I end my presentation. Thank you so much.
Yeah, thank you for your interest presentation and sharing valuable finding, Dr. Azif. Next, we have the fourth keynote speaker, Dr. Pramod Nair from Flinders University, Adelaide, Australia, maybe online. Dr. Pramod Nair will speak on trace amine-associated receptor 1 or TAAR1, the implication of genetic mutation in drug discovery and personalized treatment. Maybe Dr. Pramod, can you hear me?
Yes, can you see my slides, okay?
Yes.
Can you hear me, okay?
Yes, I hear you. Maybe committee can slide. Okay, before presented, I will read curriculum vitae of Dr. Pramod Nair. Oh, okay, maybe Dr. Pramod Nair, time is yours.
Okay, thank you so much. Thank you. Thank you so much for this invitation to present in this Malang International Conference on Herbs and Toxicants, and I would like to thank the organizing committee for giving me this opportunity, and a specific thanks to Rio Resandi and Sa for inviting me for this presentation on trace amine receptor and implication for genetic mutation in drug discovery and personalized medicine. So just to give you a little bit background regarding my journey in science and research. So I was born and brought up in Mumbai, India, and I did my bachelor's undergraduate study in Bombay College of Pharmacy, then moved to National Institute of Pharmaceutical Education and Research in North of India, did my master's, and then from there I moved to University of Queensland to do my PhD, and from there I moved to Flinders University to do my postdoctoral research. And since 2020, I am a research group leader in discipline of clinical pharmacology in Flinders University. So my today's talk will be focusing on trace amine receptors. So these are specific receptors found in different parts of the body, mainly associated in the brain. So So trace amine receptors are G protein coupled receptors which have a 7 transmembrane region, and broadly the trace amine receptors are classified into 6 different categories as TAR 1, 2, 5, 6, 8 and 9. So trace amine receptors mainly are activated by trace amines, which are small amines, small molecules. And recently, in the last, maybe in the last year or so, there have been like more than 25 cryo-EM structures of trace amine receptors. So trace amines, what are trace amines? So trace amines are biological amines, which is also found in body and also can be obtained from diet source. So which are found in very low levels in our body, which is 1 to 100 nanogram per grams of tissue. And mainly the diet source of trace amine could be like meat, cheese, chocolate and fermented foods, such as which is rich source of tyramine. And also trace amines are formed in the body by conversion of amino acids like phenylalanine to phenylethylamine, which is the most potent trace amine in the body. These are generally converted by aromatic amino acid decarboxylase into a specific trace amine. So just as this specific talk is based on herbs and toxicants, my research is not in this area. I thought I'll just put one slide talking about how this has an influence on the trace amines. So toxicological effects of biogenic amines, which are generally in the food. So the biogenic amines found in the food can also get to a toxic levels due to the microbial activity, and the ingestion of these foods can cause toxicity at high concentration. So this is a recent study recently published by some group. I'm not an expert in this area, but I found this to be interesting because there are certain food products, could be poultry, meat and fish products, as well as fermented food, which can have high levels of biogenic amines, which are also trace amines, and which can activate these specific type of receptors. So how does this protein work? So specifically, our research is focused on trace amine receptor 1, which is one of the important receptors identified in use of neuropsychiatric conditions. So trace amine is extensively studied, trace amine receptor 1, and this mainly functions via protein kinase A pathway. So compared to other trace amines, which have not been studied very significantly, but the trace amine receptor 1 has a very significant role in neuropsychiatric biology, as I mentioned earlier. So how does this protein work? Technically, you have your TAR1, which is trace amine receptor 1, which is generally bound to a set of G proteins, which is G alpha, G beta and G gamma. So upon the ligand binding, there is a dissociation of G alpha and beta gamma subunits. And once this subunit is detached, it binds to adenylyl cyclase, and then it leads to formation of cyclic AMP, and the cyclic AMP activates protein kinase A. So this is generally called as a GS signaling mechanism. So in TAR1, the GS signaling mechanism is very predominant, and most of the biological amines or trace amines activate TAR1 via this GS signaling pathway. There are also other signaling pathways shown for trace amine receptors. This is a different signaling pathway called as a GQ pathway, where there is an activation of PLC, which activates with leads to the formation of PIP2, IP3 and DAG, and when IP3 activates the release of calcium, and the calcium activates protein kinase C. But for this study, we are specifically focusing on the cyclic AMP mediated GS pathway. So what's the expression of TAR1 in the body? So TAR1 is expressed in several different tissues, including stomach, heart, intestine, thyroid. and they are very highly expressed in the brain, specifically in prefrontal cortex, amygdala, and dopamine-rich and serotonin-rich regions of the brain. Now, it is interesting to see that TAR1 is used as a therapeutic target for numerous neuropsychotic conditions like schizophrenia, major depression, anxiety disorders, and sleep disorders. And there are two compounds which are in clinical trials, which is ralmitron by Roche and Eurotron by Sumitomo Pharma. And there have been numerous experimental structures of TAR1 in presence of various ligands, and various functional studies have also been done, and new repurposed compounds have been identified which can also activate TAR1. So in this specific study, what we were trying to look is whether there is genetic mutations in TAR1, because genetic mutation can impact the way how the drugs can bind to the receptor and how it can function. So in this specific study, what we looked at was, sorry, my screen is a little bit, just trying to arrange my screen. Okay, so as you could see, there is like in this specific study we looked at classifying the TAR mutations found in different population based on the geographical regions. So this is a WHO classification, and we use this WHO classification to mine the Genome Aid, which is a publicly available genetic database. And within this database, we tried to classify the genes, TAR1 gene mutations, and we found that so the most highest number of mutations were found in African region, followed by Southeast Asian region, and then in the regions of America. And we could technically map every individual TAR1 mutations in this specific protein and how they were distributed across globally. So if you could look at this specific protein structure, this is just like a cartoon representation of TAR1 structure, and we could see there are different levels of mutations found in different regions of this protein, which is in the extracellular domains, and intracellular domains, as well as the transmembrane domains. So we were able to specifically identify this region, and we were trying to study whether this have an impact on ligand binding. We used protein structural information to see if there are specific areas of the protein which is associated with this variants. Some of the regions fell in the ligand binding site directly, whereas some of these were in the other parts of the protein which is important for signaling, like this is a microswitch region which is important for G protein binding and all those regions. And based on this is a river plot. Based on this river plot, we try to classify which regions have the most burden. As we said earlier, there are like certain regions like Southeast Asian region, there are more number of mutations in the binding site specifically, followed by European regions as well. We looked at specific drugs or endogenous compounds where there is a specific amino acids involved in interaction with these specific ligands, and we identified that certain regions of the protein might be more vulnerable for this loss of function because of these mutations. So our findings from this study was there are around total 290 missense variants were found in the data sets. This is looking at the whole of publicly available database with TAR1 mutations. And we found that structural mapping showed that 40 variants might influence directly the TAR1 activation by both endogenous and or exogenous ligands. We specifically identified that variants that is D103, which is very important for binding of trace amines were found in certain regions such as Western Pacific regions and Southeast Asian region, and signaling variants were found in specific regions which can alter the activity of TAWAN. So overall, we concluded that agents targeting TAWAN may have differential therapeutic outcomes in geographically diverse population, especially given most variants are predicted to reduce ligand binding. So now we wanted to look more towards, this was the population-wise distribution. We wanted to specifically look at these changes from a neuropsychiatric patient point of view. So we did some little bit of more research in this area to see how these TAWAN mutations are distributed in patient population, and we found that patients with obsessive compulsive disorders or bipolar disorders have TAWAN mutations, and also they have a family history of mental disorders. So these also give us some link that TAWAN mutations might be associated with associated with some mental health conditions. And most of these variants lead to loss of activity in functional assess. So based on this, we had two major questions. So one question was whether TAWAN mutation cause neuropsychiatric disorder, whether if you see if there is history or family history of mental health disorders, and if you find mutations in one specific patient population with some specific neuropsychiatric disorders like bipolar, or OCD, or schizophrenia, whether there is a link between mutation present in the previous generation and in this generation. And that is the reason for neuropsychiatric condition. And the second question we had was whether the drugs discovered for TAWAN specific therapeutics, will they work on TAWAN mutations, or we need to alter the dose in patients where there is a TAWAN mutations. So in terms of signaling, we see there could be differences in the signaling when there is a mutation in the TAWAN protein. So we wanted to inquire this in detail. So interestingly, we found a case where this was the first study on TAWAN, which showed that the affected mother and child who had diagnosed with schizophrenia had positive mutation, TAWAN mutation, and there was another child that same mother had no diagnosis for schizophrenia, and it was negative for TAWAN mutation. So this was quite curious to note that there could be some link between diagnosis of schizophrenia and TAWAN mutation, and the negative mutation for TAWAN had no schizophrenia, so that was some sort of an associated link. When we looked at the structure of TAWAN protein, we found that this specific position of this 182 was in the lid region of the TAWAN protein. So we wanted to investigate this further through experimental studies. So what we identified here, so what we did is we generated this mutant in HEC293 T cells, and we tried to find whether there is a functional loss of this specific mutation for both endogenous and clinical trial compounds. So what we found here is when we have the tyramine, which is our endogenous ligand, and phenylethylamine, which is an endogenous ligand, we see good activity for both wild type forms in all the three compounds, like the endogenous and the clinical compound. But when we have this mutant, we see complete loss of activity. So this clearly shows that the mutation in C182F will lead to complete loss of activity, and if the patients are given this specific compound or the clinical drug, this might not be functional. Likewise, if you look at the PEC50 values, you could clearly see there is a significant increase in the EC50 values for these compounds. And we also used a homozygous and heterozygous condition to see if the patients have both the C182F from both the parent when we see there is complete loss of activity, whereas in the heterozygous state there is some retention of activity. We try to find out whether there is the loss of activity is due to some sort of surface expression issues. So we looked at surface ELISA based techniques to see if there is decreased expression of these specific protein on the HEC293 cells. So this is a simple assay where we have your protein with a tag, with the HA tag, and we have an antibody which binds to this specific tag, and then we can quantify this through surface expression studies based on fixed cell studies. And what we observed here is compared to the wild type, there is significant decrease in the both heterozygous and the homozygous. There is almost complete loss of activity. And when we look at the surface expression, the surface expression is gone to about 50% in case of the homozygous state, and in heterozygous it's almost like 30% loss. So despite the 50% loss, we expect some activity because it's not completely lost, but we see the activity is completely lost in this case. The next what we wanted to do is we wanted to see what's the molecular mechanism of this loss of function of this 182F mutation. So we went ahead to do molecular simulations. We wanted to see what's happening there in the receptor binding site. So when we perform the molecular simulations, what we see is there is a formation of aromatic cluster around the lid region, and which prevents the binding of ligand. So we clearly see during the simulation time scales that this 182F moves towards the lid region and forms sort of a steric clash, or not steric clash in the sense, a steric occlusion for the ligands to get in and bind to this specific receptor and activate the receptor. So the conclusion of our work is our data demonstrates that TAR1 variant completely ablates the receptor GS signaling pathway, expresses altered membrane trafficking properties, and induces steric hindrance at the orthosteric site. So this work was focused specifically on GS signaling pathway. We look forward to work on the GQ and other signaling pathways to see if those pathways are activated in this specific protein. And together with these findings, we say that rare TAR1 variants in endogenous trace immune signaling and the development of future TAR1 based neuropsychiatric therapeutics should be focusing mainly also on TAR1 mutations. So with this, I've finished my today's presentation. I would like to thank all of those who are involved. So in our group, we do a multiple range of structure function studies, which is also on different targets, which are non-membrane bound proteins, which are some of the targets are based on the cancer targets, which is where discovery of novel compounds for cancer targets, and we are also looking at the schizophrenia and neuropsychiatric drug targets for TAR1. We have our group has a lot of collaborations both nationally and internationally. So some of the work which we do on SIPs is collaboration with University of Sydney and National University of Singapore, and then we have collaboration with a university in Dresden on a DDH1 protein. And the TAR1 study which I showed today was based on a collaboration with Monash, and some of the work was done by some of my PhD students. And we have other range of collaborations on this space. I would like to thank also the national funding body, Medical Research Future Fund, NHNMRC for funding this project, and National Computing Infrastructure for the computing facility, and Flinders Foundation and Flinders Cancer Center for all the funding. I thank you all for your time and happy to take questions.
Thank you for Dr. Pramod for your insightful presentation and sharing your finding. And finally, we will hear the last speaker. She is beautiful speaker. Give light in the room. It's related with the topic Dr. Fatin Nazira Zakaria from University Teknologi Mara. Give applause for Dr. Fatin. Dr. Fatin will be presented about cannabinoid in Alzheimer, like at the end of the tunnel. Maybe before Dr. Fatin presented the topic, I will read CV. Dr. Fatin Nazira Zakaria, position senior lecturer, Faculty of Health Science UTM, Puncak Alam Kampus Selangor. And education background, Dr. Physiology, PhD in Physiology in Malaysia maybe. Master Science, Pharmacology and Bachelor in Biomedical Science. Research interest in cognitive neuroscience related with my interest. Behavioral study, brain research, phytomedicine, and recipient of several nation and international research grant in the field of neuroscience, cognitive and biomedical research, and professional member Malaysian Society Neuroscience and Health Profession Medical Laboratory Neuroscience and Malaysian Red Crescent Society. Dr. Fatin, time is yours.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Okay, and a very good morning to everyone. How are you today so far? Is it still okay? Still energetic? Alright. So since I am the last presenter for today's keynote speech, so I try my best to finish up my presentation as soon as possible. Alright. Okay, so don't worry. Alright, and then the topic that I choose for today is cannabinoid in Alzheimer's disease, light at the end of this tunnel. Right. So to begin with, all right. So this is some of the overview of what is Alzheimer's disease is all about. Have you seen, based on the picture, what do you see about this picture? On the top, you can see the healthy neuron, isn't it? And the bottom part, you see the degenerative neurons. So at least you can differentiate when we talk about Alzheimer's disease. So basically, when we are talking about Alzheimer's disease, or also known as AD, it is actually the age neurodegenerative diseases that distinct from a normal aging, which associated with cognitive and memory decline. And the major pathological hallmark of the AD, you can recognize by, number one, if you can see, there is the accumulations of beta amyloid peptide, that is number one. And number two, you can see there is hyperphosphorylated tau protein. So what happened is these excessive productions of these two compounds will lead to the formations of senile plaque, and another one is NFTs. NFT is stand for neurofibrillary tangle. So what happened next? So based on this diagram, after productions or after formations of this tangle and senile plaque, there is causes the massive synaptic loss, whereby there is a lost communications between one neurons to another neurons, and at the same time it can causes the neuronal cell death, so which leads to the cognitive impairment. So basically that is a summary when we are talking about Alzheimer's disease is all about. Alright, so this is the AD world projections, whereby according to the AD associations in 2023, it was currently affecting over 36 million people worldwide, and it will be expecting to increase up to 106 million in 2050 if there is no intervention taken. Like our country in Malaysia, for your information, according to the AD Foundation Malaysia, it is approximately 50,000 suffering with this disease. So from that, this condition has created a demand in order for us to discover a new compound, to find out the new approaches or the new strategies specifically on how we can reverse the disease progressions by targeting the various aspects of AD pathology. All right, so when we are talking about the types of AD itself, basically it can be divided into two. The first one is called familial AD, and the second one is the sporadic AD. So even though there is two different categories of the AD, which mean familial AD is more due to the genetic inheritance, and sporadic AD is more due to the environmental factors. But if you can see based on the flow chart, the disease progression appear to be the same, whereby at the end they will develop the senile plaque and tangle itself, right? So when it comes into the stages of AD, so it can be divided into three main stages. We have mild, moderate, and severe. All right, so the early stages of AD, it can be presented by cognitive impairment, meaning the individual having the difficulties in remembering the daily routine tasks. This is the early stages. As the disease progresses, it can be presented by neuronal damage, long-term memory loss, and some of time they are having some of the behavioral issues such as agitation, sleep disturbance, and others. All right, and then when comes into the severe stages of the AD, of course, there is development of the senile plaque as well as the tangle, which lead to the shrinkage of the brain tissue, particularly at the hippocampus brain region. So why hippocampus? Because hippocampus is a crucial brain component that is involved in the learning and memory processes. So that's why when these two pathological markers attack the hippocampus itself, it will lead to the cognitive impairment. All right, so talking about the pathogenesis of the AD, it is quite complex actually, and until now it is remain uncleared, or what we say remain unexplored. All right, so there are many hypotheses describing the pathophysiology of the AD, but largely approaches are more focusing on the interventions of beta amyloid cascade and tau biology, meaning to say that most ongoing effort is more focusing on finding on the specific compound, particularly target on reducing the formations of the senile plaque as well as the formations of tangle. All right. All right, so when it comes into the therapies of the AD, for your information, currently only 6 approved drugs available to treat AD worldwide. 6 approved drugs available to treat AD, and this existing treatment is symptomatic, meaning to say that they just treat the disease based on the disease symptom. All right, and at the same time, some of the treatment may be produce some of the detrimental side effect with limited efficacy. So from that, we have to think about it. We have to discover more and more compound, particularly in reverse the disease progression. The premise is that if we can slow down ataupun we can delay the process of the disease progression itself. All right, so from that problem of the statement, my research is try to explore the compound by focusing on the potential of the cannabinoid system. Yeah. So when we are talking about the cannabinoid system, in the mindset we just focus on ganja, right? Cannabis plant. But previously when we are talking about a cannabis plant, it will produce the negativity impact. But our research try to focus or to find out the positive impact of using this cannabinoid compound, particularly in treating the Alzheimer's disease. All right. So in my research, there are consisting around 100 active compound from the cannabis sativa plant, but our research is only focusing only 2 active compound. The first one is delta 9 THC, which is the primary psychoactive compound. Don't worry, we are using the non-psychoactive doses, not the psychoactive doses of the THC. That is number one. Number two, we are using the CBD, stand for cannabidiol. Alright, so at the moment, for today's presentation, I will present the data, the effects of the THC in order to slow down or reverse the disease progressions of the AD. Unfortunately, for the CBD result, it is still under ongoing investigations. Alright, so what we try to investigate in terms of first neurobehavioral changes. Is THC can reverse back the, what we call it as the behavioral changes that is occurred in the AD animal model. That is number one. Number two, from the observation ataupun from the behavioral itself, we have to confirm it with histological and some of the molecular work. Alright. Alright, so this is some of the previous study done by the other researchers on the THC, but they all is more focusing on the effect of the THC in the normal rats. So from that result, okay, it comes the ideas for me to explore, is it the THC can reverse back the AD progressions or not? Alright, so this is the structure of the hippocampus. Knowing that the brain structures, when we are talking about the brain structure itself, it can be what we call it as categorized into the several components. We have cerebrum, we have cerebellum, we have medulla oblongata, we have thalamus, and so on. But the question is, why hippocampus? So hippocampus has been chosen in my research study because first, it played an important role in the learning and memory process, and it is a special structure due to its ability to remain plastic. Means the main functions of the hippocampus is they will form the short-term memory and long-term memory. So any effect of the hippocampus itself can lead to the cognitive impairment. Alright, so since hippocampus is really important in learning and memory process, of course they have their own pathway. So this pathway is called hippocampal synaptic pathway, whereby the input will be sent from one destination to another destination. So this process is called a process of synapse. So this is the pathway, alright. It begins with the entorhinal cortex, alright. So entorhinal cortex will send the input to the dentate gyrus through perforant pathway, and then from the dentate gyrus, the input will be sent to the CA region, alright, to the mossy fiber, and later on it will be proceeded to the CA1 region, and then back to the entorhinal cortex to complete the loops of the synapse. So basically this is the whole process on how the information can be transmitted and can be integrated and convert into the short-term memory as well as long-term memory. So that is the important part of the hippocampus itself. Alright. So there is another term that is closely related to my research. We are called on the neurogenesis. Alright, so basically what is the neurogenesis? Neurogenesis is the process of generating of new neurons. How the new neurons can be generated. If we can relate to the AD progressions, alright, there is a lost communication, right, between one neurons to another neurons due to the neuronal cell death. So if we can find out any of the compound that can promote the neurogenesis activity, it will give the beneficial effect. All right. So this is some of the overview the whole stages of the neurogenesis, whereby it can be divided into several stages. We have proliferations, differentiations, migration, maturation, and integration. And bear in mind, in every single stages of neurogenesis, we can detect it using the specific cell marker. So that's why we need to investigate either the cell marker is functioning or not. So basically, the hypothesis is higher expressions of this cell marker, it will represent that generating of the new neurons, right? Alright, so when it comes into the research methodology, basically my research focusing on the animal models. We are doing on the, specifically on rats. Okay, so this experimental design was divided into 6 groups. We have a control group, and then group 2 represent on the AD model, whereby we use 2 chemical inducer, combinations of D-galactose and aluminum chloride to induce AD model in the rats. And then group 3, we try to treat with the established drug, okay, which is donepezil. And group 4, 5, 6, we want to investigate the potential neurotherapeutic effect by using 3 different concentrations of the THC itself in order to reverse back the AD progressions. Alright, so this is the parameter that we investigate. Alright, so we start with the behavior, some of the behavior for specific tests being conducted. Okay, we have NOR. NOR stands for Novel Object Recognition. And then we have Morris water maze. And then we have modified elevated plasmids. And we have another one is elevated plasmids itself. So basically all of these neurobehavioral study is we want to test for the learning and memory effect as well as anxiety-like behavior. Alright, so from the behavior effects, we have to confirm it with some of the morphological changes using the specific staining, and then proceed with the molecular study. Specifically, we are doing on the Western blotting part. Alright, so this is some of the overview how the NOR being conducted. So I'm not explaining in details, but I can share the basic theory of the NOR itself, whereby actually this test is based on the spontaneous tendency for the rats to explore the novel object rather than familiar one. Alright, there is a specific durations of time whereby the time of the rats to explore both of the object was recorded. So basically in the normal condition, it should be, okay, spending more time in the novel object rather than familiar one. So what happened is, alright, so this is the result for the NOR. We can see that, okay, THC exhibited an increase in the normal object exploration, demonstrating their cognitive ability and improved non-spatial memory. Alright. So what happened to the AD model? If you can see based on the diagrams, based on the graph at the below one, the explorations time between novel object and familiar one is almost the same, meaning that they have difficulty to differentiate which is familiar one, which is the novel one. So it represents the cognitive impairment. Alright, so this is the second behavior that we being conducted, which is called as the Morris water maze. Alright, a little bit different as compared to the NOR, because Morris water maze is can be considered as the spatial learning memory. Just now NOR is non-spatial memory. Alright, so whereby in this experiment, it will basically, it is actually depending on the distal cues to find the hidden escape platform. If you can see the cylinder here is represent the hidden escape platform. So what happened is the rats need to search and navigate and locate to the hidden platform, to the hidden escape platform with the specific durations of time. All right. So this is the result for the MWM. We can see that the swimming trajectories of the AD model demonstrated the aimlessly random swimming. They have difficulty in the searching of the hidden escape platform as compared to the THC. If you can see here, I'm not sure you can observe there is 2 dots here, the red dots and the blue dots. The blue dots is represent the starting point, whereby the red dots is represent the locations of the hidden escape platform itself. Alright, so this is the device for conducting the MEPM and EPM. EPM is actually almost similar to the Morris water maze, whereby they are assessing the learning and memory. However, for EPM, it is more focusing on investigating for anxiety-like behavior. Alright, so this is result for the EPM. Significant increased time spent in the open arm in all treated groups, suggesting that the rats exhibit anti-anxiety behavior. So from the result of the behavior, we can notice the positive impact of the THC itself. So from the behavior itself, okay, I will confirm on the morphological changes using the specific staining, which is called as a nasal staining. Alright, so the brain area that we focus, of course, in the hippocampus, and the hippocampus itself can be divided into several subdomains. So out of 4 subdomains, we focus only 2 subdomains, which is CA region, and another one is dentate gyrus. Alright, so this is the result for CA region. Okay, we have CA1, CA2, CA3. So what happened was, if we can focus on the result of the AD model, we can see an obvious alterations of the pyramidal cell layer, and several hyperchromatic cells was observed. And at the same time, the number of viable pyramidal cells significantly being decreased, meaning to say that there is a lot of neuronal cell death in the AD model groups. Okay, so however, in the treated groups, okay, 0.75, 1.5, and 3 mg per kg of the THC cells, the number of the viable pyramidal cells significantly increased, and from that we can conclude that THC may have the capacity to slow down the AD progression by ameliorating the survival of neuronal cells. That is another positive result from the result of histomorphological findings. Okay, so same goes for the dentate gyrus. We can see the high density of the granule cells observed in the THC treated groups as compared to the AD model groups. Alright, so from morphological changes, okay, we move on the neurogenesis activity, whereby we want to test or we want to determine if the THC enhance or promotes the neurogenesis activity by looking the specific cell marker. So in our study, we focus 4 cell markers, which are known as GFAP, and then we have DCX, okay, double coating, and then we have NEON, and the last one is calbindin. So in summary, I can conclude that by administrations of the THC, all of the cell markers that is involved in the neurogenesis activity become elevated, increase. Alright, so this is the result for neurogenesis activity. And then when comes into the last, that is the important part. Alright, we try to look on, is the THC capable to reduce the major pathological hallmark markers of the AD? So we are trying to look on the base one, APP, and some of the hyperphosphorylated tau protein, whereby, okay, we look one by one. Okay, we start first with the base one. Base one is actually the specific enzyme whereby it will cleave the APP into beta amyloid peptide. So if we can reduce the functionality of the base one itself, so the tendency to develop the beta amyloid peptide can be reduced. So from that we can say that THC at all doses significantly reduce base 1 protein expression, suggesting that THC is able to reduce beta amyloid peptide synthesis, and at the same time it can reducing the likelihood senile plaque formation and halting the AD progressions. So another protein marker that we investigate is the APP itself. Alright, so the treatment with the THC significantly decrease the APP protein expressions, and THC may involve in the clearing mechanism event, but further investigations need to comprehend the underlying mechanism. Alright, so this is the result for hyperphosphorylated tau protein. 2 important hyperphosphorylated protein being conducted. We have THR231 and another one is THR181. Alright, so the result, interestingly, THC significantly reduced the level of p-tau for both of these THR. Alright, so in the conclusion, we can say that administrations of the THC would enhance the cognitive functions or would enhance the cognitive performance through neurobehavioral studies, and that is number 1. Number 2, it will decrease the neuron degenerations through morphological changes, and then it also increase the neurogenesis activity and also decrease the expressions of pathogenic proteins markers. Alright, so this is my future research. Okay, in terms of the THC and explorations in details, the key pathway through the THC is that its beneficial neurotherapeutic effect in AD should be tested actually. And then that is number 1. Number 2, we have to explore more and more in terms of the toxicological evaluations of known psychoactive doses of the THC in different animal models. Okay, like us, currently we are using the rats. Maybe we can test with a different animal model such as zebrafish and so on to establish our result before we go to the clinical trial. And then detailed explorations on pharmacokinetic of the THC need to be determined. Alright, so this is the future research of the THC that we are planning to do after this. Alright, there is another research on the second compound, which is CBD, which is still ongoing investigation. So we try very, very hard to find out the result, what is the effect of second compound of cannabis sativa on treating AD. And then the newest project that I planning to do with my students is we try to explore the effect of persistent caffeine exposure by focusing the neurodevelopment and behavioral changes, a little bit different from the Alzheimer's disease because the Alzheimer's disease is towards the saturation processes end of my project actually. Alright, so before we end our sessions, okay, so I would like to share some of the students that struggling for data collection processes, and with that, okay, thank you for your attention.
Thank you for your wonderful presentation, Dr. Fatin. And I hope we will collaborate about your research next time. Okay, ladies and gentlemen, we have now completed our keynote presentation for this session. To enrich our discussion, we will now open question and answer session. I hope all participants be active. Maybe there is the first 3 questions. Okay, raise your hand, introduce yourself, and address your question to the specific speaker.
Okay, Assalamualaikum and good morning everyone. So my name is Amar and I'm from UiTM, Shah Alam, Malaysia. So I would like to ask Dr. Chin. Good morning, Dr. Chin. A very great presentation. So my first question is, as you emphasizes the as you emphasizes the tocotrienol, in treating the osteoarthritis, so as well as for Prof. Tan Kok Leong as well. So I would like to know, is there any product or supplement in the market associated with tocotrienol? And are you planning to proceed with your findings, in the next stages such as clinical trials? And last but not least, I would like to know what makes the tocotrienol outstanding compared to other compounds. Yeah, that's all from me. Thank you.
Thank you. Maybe Dr. Chin can answer the question from Malaysia student.
Yeah. Thank you for the great questions. Actually, one of our colleagues actually have attempted to use tocotrienol on patient with grade 2 or grade 1 or grade 2 osteoarthritis. And from the functional score and also pain score, actually there's an improvement actually. But we are still finding a grant to see whether we can exhibit structural changes within the patients. Second question is regarding whether if we compare the tocotrienol in comparison to other products, for example, glucosamine sulfate in the market. So you can see from a study, actually the tocotrienol is performing on par with glucosamine sulfate on chondroitin as well. And if you look at the price range as well in the market, tocotrienol supplements and also glucosamine sulfate, actually they are priced almost at the same price range. Compared to other standard drug, I would say that most of the conventional osteoarthritis standard drug are just, they are treating the symptoms, not improving the structure. So you're talking about disease modifying drug, we are actually on par with glucosamine sulfate. Okay.
All right, thank you.
Thank you. Maybe the other question? Yes, the second question. Raise your hand, introduce yourself and address your specific speaker.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning. Let me introducing myself first. My name is Priscilia Veronica from Universitas Islam Malang, and I have question for Dr. Razif from Malaysia. Considering the complex gene regulation patterns observed, including those related to apoptosis, mitochondrial function, and oxidative stress, which molecular pathways do you see as the most promising targets for future mechanistic studies? Thank you.
Okay, thank you for the questions. Okay, so for me, there are many pathways that can be observed or can be researched. So it depends on your target. Let's say if you focus on the apoptotic mechanism, you can focus on any genes that related to that apoptotic mechanisms. So there's no specific target. It depends on what is your target. Okay, am I answer your question? Okay, thank you.
Are you satisfied with the answer, or maybe any question? Yes, the third question. Yeah, the answer. The third question.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Nur Intam. I am from University of Islam Malang. I want to ask for Dr. Fatin, given the promising neuroprotective and neurogenic effect of delta-9 tetrahydro THC demonstrated in animal model, what are the challenges and safety considerations that must be addressed, translating this finding into human clinical trial. Because your finding saga significant modulation of amyloid beta, phosphorylation, and neurogenesis marks. Thank you.
The question.
So thank you for the questions. Okay, one of the important of the safety considerations of the using THC is actually determinations of the concentrations itself. So just to make sure that the concentrations of the THC itself must be below than because the THC is one of the psychoactive compound, right? So in order for it to for us to investigate the positive impact of the THC, specifically in reverse the disease progressions of the AD, the determinations of the concentrations of the AD is really important. Like our research, we are using the non-psychoactive doses actually, so ranging from 0 until 5. So more than 5 mg per kg of the THC is considered give the negativity impact. So we should avoid the higher dosage of the THC. Is it answering your questions? Thank you.
Thank you. Maybe the last, I want to ask Dr. Fatin, because I'm very interested with the topic, and experimental is familiar with my dissertation examination. I want to ask you, in your animal model Alzheimer, what stage the cannabinoid give in animal model in early stage Alzheimer or late Alzheimer? It related mild cognitive impairment or severe cognitive impairment that cannabinoid is beneficial in your animal model.
So in our experimental design, we are highlighting on between the range between moderate to the severe stages of the AD. So because of that, the process of the inductions to induce the AD models was take time for the 10 weeks of the inductions process.
Yes, thank you. It's very interesting. Okay, thank you very much for the active participation and the engineering discussion. On behalf of the organization committee, I would like to extend our deepest gratitude to all our keynote speakers for their invaluable contribution and all participants for your attention. I hope we will be continue by next research, collaboration research, and short MCST next year. Okay, we wish you. I will to return to the MC. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Sinta, neurologist, for leading a great session today. And you may now be seated, Doctor. Ladies and gentlemen, for the next session, the attendees are welcome for lunch break. Lunch break starts from 11 a.m. to 12:30 p.m. Before we start the lunch break,
we would like to all the speakers to come to the stage to take a commemorative picture together with everyone. Please, to all the speakers. We also would like to present a gift to our speakers.
I would like to present our certificate for Dr. Pramat Nair. Thank you so much for attending our conference, for giving your time to us. I'm sure you are wishing to be here, and we will welcome you next time if you wish to come to Malang, and I hope you have the time for our next meeting in 2027. Thank you so much for providing your time to me, to us in FK Unisma, for giving such a wonderful breakthrough on a new topic that not many of us really know. So hopefully we can learn a lot from you in the future. So here I presented your certificate. Yeah, okay. Thank you so much for attending. Thank you so much for your wonderful speakers.
Thank you. Thank you. Bye-bye.
Bye. Okay, we would now like to present our certificate to Dr. Chin Kok Kyung.
And the next, we would like to present the gift for Dr. Razif bin Dasiman. Time is yours, Doctor. And the next, we would like to present the gift for Dr. Fatin Nazirah binti Zakaria. Thank you for all our speakers. May we proceed to the photo session, Doctor.
Yeah, let's go. Please stand up for the photo session together. We would now like to have a photo session together with the speakers and our moderators. all the participants, please stand up. We're gonna have
All the
a
audience
picture to get
stand
taken
up.
together. All right. Kita juga. One more time, okay. Okay. Please be seated, everyone.
Thank you, and we may continue to lunch break, and it starts from 11 a.m. until 12:30 p.m. Please note that after lunch break, we will proceed to the second agenda, the oral presentation and paper presentation. This agenda will be done simultaneously, so please kindly follow the committee's guidance for mobilization. For guests and keynote speakers, may follow the committee's guidance to 6th floor.
Before we head to lunch, we would like to also announce to everyone we have several booths here, which is BRI, Jatim Syariah, and Altamega. For all of you who wanted to see newest medical innovations and medical and laboratory instrument, you can go and visit their booth. As you can see in the, we also would like to thank our sponsors, which is Bank Jatim Syariah, Java Medica, Bank BRI, PT Tes Science Indonesia, Almega, Prodia, and all the sponsors shown in the slides.
Thank you. And also the winner of the presentation session will be announced later in the closing ceremony. Thank you, and we wish you all have a wonderful and enjoyable lunch break.
Thank you, everyone.
Good evening, ladies and gentlemen, distinguished guests and attendees. Welcome back to Malang International Conference on Herbs and Toxicants 2025. The effects of waterborne toxicants on health and its detoxification and mitigation.
It's very nice to see you all again, and we hope that you enjoyed the conference so far. We are also very, very excited to announce the awards for the best presentation.
And ladies and gentlemen, before we proceed to the next agenda, this conference is only possible with the support of our sponsors. So we would like to thank first Bank Jatim Syariah Malang, Java Medica Utama, Bank BRI Cabang Malang, Lembaga Penelitian Peluruhan Radikal Bebas, Institut Molekul Indonesia, ITS Sains Indonesia, Bank BTN Syariah, PT Almega, PT Firdaus Medica, CV Pratama Mandiri,
Bank Muamalat Cabang Malang, CV Jaya Rindo Pratama Laboratory, PT Rizky Putra, PT Ditek Jaya, Prodia, Herbalife, PT Wadia Prima Mulia, Sima Lab, CV Nura Gemilang, and our media partner, Riviera.
Without further ado, let's announce the awards for the best presenter. The announcement will be announced by Mr. Rio Risandiansyah, PhD. Please come forward, Mr. Rio.
Okay, Assalamualaikum warahmatullahi wabarakatuh. It's been 2 long days, and well, not really long, right? But okay, long. And today we are going to announce the winners. We start with the posters, and we'll start from the third. So, for the winner of the third, for the third winner for the poster presentation, please come forward. Zuhruf Yarusina Khalid Firdaus from Unisma. Where is Zuhruf? Zuhruf? Yes, okay, thank you. Come forward here, please. Congratulations. In here is the so that spoilers. Okay. Wait. Sorry. Okay. There you go. See? Nothing happened. Nothing happened. It was like everything is. You forgot everything. Okay. Okay. So for the second best presenter, please come forward. start for these poster presentations. So the poster presentation is based on their merit, on their content, and of course on their display, and they have to be here. So if they're not here, they don't get Congratulations for all the poster winners. Congratulations for all the poster winners. Now next is the oral presenters. So the oral presenters, today we have 34 oral presenters from various countries. So for the third winner, for the oral presenter, is Tia Amalia from University of Malaysia. She's online. She's online. So hopefully she will do. Online room. Oh, okay, there you go. Cameras off though. So congratulations, Tia. We'll go to the second winner. Please come forward. Muhammad Rifki Shindi from Taipei Medical University. finally, we are at the end of our event today. For this, the second Malang International Conference on Herbs and Toxicants. We held the first Malang International Conference on 2023, and this second one is on 2025. I want to thank everybody who has attended today, and I value very much the time and the commitment you have given to us for this conference, and I hope this conference leaves a good remark, a good memory in your mind, and you may enter again maybe whenever we hold the next one. So this conference this year, we have 34 oral presenters and 36 poster presenters. Most of the poster presenters are from our university, but for the oral presenters, we have various universities attending, from UTM, from Brawijaya, from other parts of the island, which I would say. So there's from Muhammadiyah Malang, Poltekkes Kemenkes Mataram, Taipei Medical University, Universitas Gadjah Mada, Universitas Al-Irsyad Cilacap, Universitas Brawijaya, Universitas Kebangsaan Republik Indonesia, and Unisma. So I hope to see you again in the next session, in the next conference, and I will welcome you back to our conference. And I think that's it. Yeah, I'll call you. I'll call everybody. Hey, come back. Okay, thank you very much. So I'll return it to the MC. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Rahma and Mr. Rio, for presenting the awards, and congratulations to our winners. You may now be seated all. Give a big applause for everybody. Ladies and gentlemen, we have now come to the end of Malang International Conference on Herbs and Toxicants 2025.
On behalf of our Faculty of Medicine, Universitas Islam Malang, we would like to extend our gratitude to our honorable speakers for sharing their expertise, our moderators for leading the session, and our sponsors for their generous support, and most importantly, our attendees for your undivided attention throughout the session. We would also like to apologize for any inconvenience that arise during the conference.
We look forward to see you again in the third Malang International Conference on Herbs and Toxicants 2027 on 7th and 8th October 2027.
Everybody excited? Everyone's gonna come again next 2017, so we're gonna see you all again.
We can't wait to see you again.
Okay, so my name is Taskia Azmi Salima.
And I am Abdurrahman. We are signing off. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Bye.
Goodbye. Thank
See
you.
in
See you again.
2027. everyone who would like to take a picture, you can take a picture here now. And anybody else, if you wish to leave the venue, you can leave now. Thank you. For the poster presentation, for all the presenters, for the poster presentation, you can take your poster back to your home. So please do pick up your poster. Thank you.